So, good morning, everyone. Good morning, everyone. My name is Vera. I work for Seascape Belgium, and on behalf of the Blue-Cloud Consortium, it is my pleasure to be here to guide you through the flow of this Blue-Cloud final conference, which marks an important milestone for the Blue-Cloud project. So, first of all, I would like to give you all a very warm welcome. Welcome to my home, the beautiful city of Brussels. Welcome also to the Residence Palace, where Blue-Cloud is hosting this event. We couldn't be more thrilled to have so many colleagues, so many friends joining us from all across Europe today on this conference, just in person, just as we are also thrilled to have so many colleagues joining us remotely. So welcome all, and whether you're here in person or joining us online, thank you so much for being with us, and thank you so much for sharing this very special occasion with us. We have a full day of presentations and I would say exciting discussions ahead. But before disclosing our agenda for today, I would like to start by giving way to the formal opening session of the conference, for which we're very fortunate to have two very special guests and two very special Blue-Cloud colleagues whom we've asked to join us to welcome you today. So please allow me to give a brief introduction to our guests before opening the floor to the session. Amongst us today, it is our honor to have Pierre Karleskind. Mr. Karleskind is chair of the Committee on Fisheries of the European Parliament and member of the board of the Seas, Rivers, Islands, and Coastal Areas Intergroup of the Parliament. What can I say? It is not often that we can boast having a member of the European Parliament with us, but more especially one who has crossed the Indian Ocean on board the research ship to study microalgae. So it is really great to know that you share our passion for ocean research, sir. Thank you so much for being with us. It really means a lot to us. We are also very grateful, as always, to have Nicolas Segebarth, our policy officer at DG Research and Innovation. Nicolas has been a guiding light for the Blue-Cloud Consortium over the last 3 years, also always ready to support us. So thank you so much, Nicolas, for joining us on this special day. And we are, of course, delighted to have our Blue-Cloud project coordinator, Sara Pittonet from Trust IT, and our Blue-Cloud technical coordinator, Schaap from Maritime, both of whom I would say have relentlessly led us through our efforts. So great to be able to see you in person again as well, Dick and Sara. So let's please proceed with your welcome words. Mr. Karleskind, the floor is all yours. Whatever you prefer, sir. Sure.
Okay, thank you so much. So I guess my mission is to wake you up this morning. Thank you. I think it's done. I'm so sorry. Well, as you say, I have a bit of experience on the issue you're dealing with, because I used to be an oceanographer before being a member of the European Parliament, and we were talking together just before. One of my main experiences that I defended my PhD thesis a bit less than 20 years ago, on simulation and modelization of the ocean, a small rectangle in the Atlantic Ocean that became my nightmare during 3 years. But now that's okay. Atlantic Ocean is full of things, and as the Atlantic Ocean, like the whole ocean, is full of things, we need to know. We need to know. And this is really something that, this is really a word that is said really often in the Fishery Committee. When you deal with marine policy, when you deal with trying to create a condition for sustainable management of fisheries, when you're trying to deal with the protection of the ecosystem, the marine ecosystem. Because I'm not going to repeat that we know better the surface of March than the bottom of the ocean, but this is a fact. This is a fact, and we're still dealing with how we can get some data, but also how we can use them. And I remember when I used to be an oceanographer, I've worked a bit less than 15 years in that field after my PhD thesis. That was, once more, a nightmare, to try to access the data, to know where they are, access them. I could say that this is a kind of NetCDF community meeting, today. So this is one of the formats that we have to use them, but we know also that there are so many ways of dealing with them. So knowledge is really at the basis of a good policy. This is even in the UN Convention for the Law of the Seas. This is said that for any decision you take regarding fishery, you need to take the best scientific advice. And if you want to have the best scientific advice, you have to have the best knowledge and to have the best data to create the condition for a good policy. So I was talking about my experience, my own experience. So I know how important it is for good science to have this good access. Since the beginning of my term, I've been also supporting a great opportunity given by the European Commission. I'm sorry, the next speakers will talk about it, is the Ocean Mission. The Ocean Mission at the beginning was called Starfish, but I know that it is forbidden to say now Starfish. But the Starfish Mission inside the 5 missions. In fact, this is quite, I was so delighted to hear that the Commission considered that amongst the 5 great missions for changing the world in 10 years, there is one concerning the ocean. And we are working on that. So you are part of a great community that acts to change the world. And we have put money, this is inside the multi-annual financial framework of the European Union that we voted for in 2020, or 2020, not 2020. So you can be proud of being part of this great community that acts to change the world. We are changing the world with this mission. Now it's the Ocean Mission. I was supporting it with my colleagues, so now it's on its way to give results. We hope so. And if we want to achieve one of the main projects that you are going to talk about, the digital twin ocean, we need the counterpart. We need to have the data. We need to have access to the data. So we have to be able to collect it. And Europe is a key player in the world on that. So that's why being here today is a major step for making sure that Europe will be this key player and will lead on that. We can lead on that. I would like to remind you the words of the President of the Commission. I'm the member of the Parliament, but I guess I can also talk about the Commission. She was saying, we have to go through the Green Deal, and of course there is no green without blue. I think that green without blue is yellow. So we have to, we never forget blue when we talk about the Green Deal. Europe will be the leader for the Green Deal, and we will use it to be a leader in the world for growing our growing economy. I would like just to give you one more political overview on what you're doing. With one of my colleagues, with several colleagues, we are fully involved in international negotiation where we're supporting the position of the European Union on the status of the ocean, of the icy ocean. We would like to make sure and to have written in the UN Convention that ocean is a common for humanity. Ocean is a common for humanity. And if we want to have ocean as a common, this is not a juridical point of view. This is an ethical point of view. We have to be sure that ocean is shared all among the humanity. And if we want to have it, we need to manage it sustainably. And if we want to manage it sustainably, we need to have access to it. And what you're doing is to give us access. But free access, common access, this is what you're doing. This is why it is really important. This is why your project, Blue-Cloud, is so important. I understand that it's not only the final conference of the project, but a step towards a second great project. So thank you for what you've done so far, and really good luck and all the best for what you are going to do together. Thank you.
Good morning, everybody. Tout d'abord, laissez-moi remercier Monsieur le député Karleskind, qui nous fait l'honneur de sa présence aujourd'hui. It's an honor, of course, to have him, but a pleasure and a huge opportunity considering his activities in the European Parliament. You heard about it, and the fact that he is himself an oceanographer. I don't think many around share these two excellent qualities. So I think it is an opportunity for us to further engage with you and maybe work together under the mission and the digital twin ocean, and we will come back to that. So I'm absolutely delighted to co-open this final conference of the Blue-Cloud project, partly because it's the very first project that I started following when I joined the ocean unit in DG Research, but also because Blue-Cloud is a flagship project that paved the way for the major next innovation in the realm of ocean knowledge, and that is the ocean digital twin, which we already mentioned, and I will come back to that in a moment. So you will hear today about the achievements of Blue-Cloud, an initiative that was promised back in 2016, so 7 years ago. And if I mention that, it's not by pure anecdote, but it's to remind all of us of the timing and the time scale of science, and that science needs to have a very forward-looking approach to the problems and to the solution of tomorrow and after tomorrow. So we need to have that long perspective if we want to solve tomorrow's problems. You will hear today about the power of combining multidisciplinary data with analytics, with computational power, with virtual research environments. But more important, you will hear about how this can serve the real needs of the ocean communities. And this is really key in our view. We need to serve the ocean communities, the stakeholders, and make changes. And you will see example today from biodiversity assessment, environmental monitoring, and science. You will hear about two very telling demonstrators on fisheries and aquaculture. So I hope you will see that Blue-Cloud is actually a plea for open science across borders and across disciplines. I mentioned that Blue-Cloud paved the way for the next great endeavor, the digital twin of the ocean. By now, and it was already introduced by Mr. Karleskind, you have heard about the EU missions. The EU missions are new instruments under the EU Green Deal that are rooted in science, but that are mobilizing and leveraging on a much broader range of initiatives. They are meant to be transformative and to bring concrete solutions to the greatest challenges of our time: cancer, adapting to climate change, protecting and hopefully restoring the health of the oceans and of the inland waters, living in greener cities, entering healthy soil and healthy food. The mission will engage with all Europeans. You perfectly framed it, Pierre. You are part of the mission. So it is about what we can do together to shape the world we want to live in. In particular, the mission, Starfish, we allow some exceptions, in particular from the French side and Pierre Lamy. The mission Restore Our Ocean and Waters by 2030 has three main objectives: protect and restore marine and freshwater biodiversity and ecosystems, eliminate pollutions, and make the blue economy carbon neutral and circular. And all these objectives come with very, very clear targets. But we also need to be clear that there is no way we will meet any of these targets if we do not ensure an excellent cooperation and synergy with a vast array of programs, of initiatives, and of people. And this is why I invite you, all of you, citizens, businesses, organizations, projects, to sign up the Mission Ocean Charter and commit to work jointly with you. And you can Google very easily, find the charter, see what it is, and join us. The Mission Ocean also requires that we work on two key enablers: citizen mobilization and engagement. We won't do anything without the people. And a digital ocean and water knowledge system. The EU digital twin of the ocean is going to be a main deliverable of this knowledge system. Under the Mission Ocean, we will integrate and federate our main EU marine assets, like EMODNet, the Copernicus Marine Service, research, infrastructure, and projects. And I have seen somebody from Iliad, the Iliad project, which I all recommend you to follow, which is also about digital twins of the ocean, and which will participate to this great endeavor. And this EU DTO will allow everybody, scientists, of course, developers, national and local authorities, businesses, and citizens, to access a wealth of data and model with tailor-made tools to future-proof their decision-making with actionable knowledge and what-if scenarios. So it is really what we want to develop, is a tool for people to make well-informed decisions and to understand the impact of their decision globally. So I hope that you will see today the potential of the DTO, thanks to the great work of Blue-Cloud, and in particular of these demonstrators, which I consider as precursors of what the DTO can offer in a soon future. So without further ado, and beyond congratulating the whole Blue-Cloud consortium for the work, but also for getting the follow-up grant, which I encourage to bring under the DTO initiatives, I am very pleased to pass the floor to the coordinator, to Dick and Sara, and I will now turn myself into a listening mode, a very interested listening mode. Thank you very much.
Thank you very much, Nicolas. And thank you all for being with us today. I'm really pleased to welcome you all to this final conference of the Blue-Cloud project, which we know already is not the final act of this great play that started 3 years ago, but actually that relies on the shoulder of a strong and established community who have been dealing with these challenges for over 10 years now. So we have learned from Monsieur Karleskind talking about the community. That's what Blue-Cloud also brought in. Today, we'll show once more how the Blue-Cloud services explore and demonstrate the potential of cloud-based open science. And we will also see how Blue-Cloud is one fundamental piece of a bigger set of actions that together can contribute to the successful evolution of the digital knowledge system required to support the EU Green Deal, the missions, the European Commission missions that were mentioned before, and the United Nations agenda towards 2030. And the evolution of Europe's fair digital ecosystem in support of applied research for oceans, European seas, coastals, and inland waters. Blue-Cloud has achieved significant results since the start that can work and proved to work in truly interdisciplinary context. The Blue-Cloud Open Science platform introduced what we call a de facto federation, taking place at 3 levels. So we have the level of the data, and we learned about this later on in the following sessions, at the level of the computing resources, and at the level of the analytical services. For each of them, Blue-Cloud orchestrated mechanisms that successfully established interoperability and which resulted in a data discovery and access service in a virtual research environment and in 5 virtual laboratories spanning different disciplines. Blue-Cloud working environments are serving today more than 1,300 users spread across 20 countries. 15 services released by Blue-Cloud are now available through the EOSC marketplace. Up to September this year, more than 25,000 working sessions have been executed with an average of 1,200 working sessions a month and 55 analytic sections executed every month by the users of the virtual labs. Even more, Blue-Cloud has established synergies in the open science, blue economy, and marine research fields with other infrastructures, blue data infrastructure, and EU-funded projects, as the project team has always believed that through collaboration and cooperation with initiatives operating in the same field, the value of the Blue Cloud services increase. And many of you are here today. Today, we'll have the pleasure to listen to many different actors contributed to make Blue Cloud a success, from the core team behind the Blue Cloud platform up to some of our end users, but also actors that represent the future and way forward for the exploitation of what Blue Cloud has built so far. My wish is for you to enjoy the event and think of how Blue Cloud can serve the needs of your communities. Thank you very much.
Hi, I must say I'm also very delighted to see so many people and so many participants, let's say, joining this event. Because Blue Cloud, I've been working on marine data management, ocean data management for more than 3 decades, so not many people can say that. I've been at the foundation, I would say, of part of the European landscape for marine data management, ocean data management. And we have set up the very successful SeaDataNet cooperation with all the, say, the network of national oceanographic data centers. And later we went into an adventure which was called Sea Data Cloud, where we say we have to explore the options and opportunities from cloud technology. And that was in fact one step further, let's say, one step, I would say, a step forwards to what we did in the Blue Cloud, because the Blue Cloud was, I would say, a new horizon, especially combining the marine community requirements and ideals together with also the upcoming European Open Science Cloud and modern technology for working, let's say, sharing and collaborative work in the cloud and web-based science, more open science, because in the days that I started, all the data was, in fact, there was no open data. So, but over time, of course, this has changed a lot. We still have some areas where we can do better, but I must say also to satisfy or to help also our colleague from the European Parliament, let's say nowadays it's much more easy to get access to data and also have very good, fine metadata that really document the data and the quality, so you can much better make a judgment whether it's fit for purpose. And that's something that we, with the whole fairness movement, let's say, that also finds its roots a long time ago, but of course in a certain moment somebody named it, and by that moment on it became a phenomena, I would say, fairness. And this way, I think by working on this, we really are reaching out to higher goals, and that was also said by Nicolas. Let's say we are looking now for this digital twin of the oceans, and by having the Blue Cloud together with ABUDnet, together with Copernicus Marine, also together with all the research infrastructures that really are the underpinning values and the networks by which we reach out to all the data coming from all the different observations and research, those all together, let's say, can really provide the framework for a DTO that can be successful and then really can give us the answers and also the let's say the what-if scenarios that we want to run to be able to manage better and to restore our oceans. And in that sense, I'm very proud that I was the technical coordinator of Blue Cloud, and again for the successor. And I think we are going higher and higher, but also wider and wider. So let's say the base is getting stronger, but also we're reaching out more to the top. And that's something that's an achievement of all of us, also all the people here in the room, because you all are partners in the Blue community, and there are many more, of course. And also we have many projects that we are, let's say, interacting with, and that's also part of the integration value that we have, that we are not doing it all in a singular pillar, but we really are interacting with all the different initiatives and make sure that we reuse and reproduce and interoperate with each other on a fair basis. And this way are able, let's say, all of us to get out what we want and reaching that ultimate goal that we can support a DTO. And of course, restore the oceans with all the knowledge that we gain from the data. Because as you know, the data cycle is very important. We go from data to information, to products, to knowledge, and then to wisdom. Wisdom is very difficult, but it's always the ultimate challenge. Okay, I won't make it longer now, but I want to thank, of course, everybody for being here and attending. And what I want to do, I want to start now with the panel. And maybe Judah, you want to do a short answer, or shall I continue? Okay. Now we're going to do a short panel. So I would like to thank our distinguished speakers. And also would like to ask them to step down from the podium and to be replaced by our panel members. And they're coming forward. for the first session.
So, thank you very much indeed, Pierre, Nicolas, Sara, Dick, for getting us started. Indeed, please join us in the audience as we get ready to kick off. And let's now look deeper into the Blue Cloud. I'm going to ask my Blue Cloud colleagues to please join us on stage. So Patricia, Lino, Massimiliano, you all know who you are. And while we get the panel ready, in the meantime, please let me give you a very quick overview of what we have in store for you today. So we have divided our agenda in two parts. This morning, following this welcome panel, just now we plan to give you an overview of the key results and achievements of the Blue Cloud project, coming straight from some of the colleagues who have orchestrated this work. After this panel, we will break for lunch, and we've planned for a 1-hour lunch to stretch our legs a bit and to rebuild our energy. And after lunch, we will be looking at the road ahead for Blue Cloud. I will be giving you an overview of the Blue Cloud roadmap to 2030, which provides a strategic outlook and recommendations for the future evolution of Blue Cloud. And we will then give way to 2 roundtables, in which we will be discussing how Blue Cloud can further evolve to connect and to bring value to key initiatives in the wider open science and marine knowledge landscape. And I have to say that we're privileged to have an extraordinary group of speakers from different backgrounds and initiatives that will join the conversation on board these roundtables. A conversation that will be facilitated by Sara Pittonet from Trust IT for the first of the roundtables, and by my colleague Kate Larkin from Seascape Belgium for the last of the roundtables that we will have today. If you make it to the end of the day with us, there's a prize. We will be hosting a networking drink and an aperitivo to give everyone the opportunity of more informally interacting with each other. So please do stay with us, and please join us for a drink at the end of the day. We're already looking forward to that. And maybe before giving the floor to my colleagues, I'd like to say that we really look forward to engaging you in our conversations and in our discussions today. The beauty of this venue is that each chair comes equipped with a microphone. So please make sure that you find your way to the microphone which is in your seat. I'm actually tempted to ask for a volunteer that might help us check whether the microphone is working. Anyone? Alexander, maybe? Do you want to find your microphone and quickly test it? Or whoever is faster.
Test.
We'll give a free drink to the faster
that's working.
microphone. We just want to make sure that you find it, that you know how to action it. I think you have to press start.
Hello.
All right,
Test.
We have a winner. Okay, so the microphone works. Thank you so much. We've planned for a Q&A session after each of the panels. There will be plenty of time for you to use the microphone, but for now, just know that we're well equipped and really looking forward to a productive discussion. For those of you joining us remotely, unfortunately, we cannot bring your voice to the venue, but we can bring your questions. And we have actually set up a Slido channel. You can see the information on the screen. #BlueCloudFC. So if you have any questions, if you want to share any thoughts, please do write us via Slido, and we will be checking throughout the event, and we will make sure that we convey your questions to our panelists also throughout the event. So I think that's all from me for now. So Dick, if we're ready, over to you, sir.
Mm-hmm.
Yep.
Do we have the mouse, because it fell down?
It fell down?
Yeah. Just useful activity.
There we go. So to pass, it's the green button.
Okay.
All right.
Okay. Now I have the honor, let's say, to chair this panel 1, which is about the Blue Cloud in a nutshell. And I must say it's 1.5 hours, so it's quite a big nutshell, but okay. We will present, let's say, the results, the achievements, and the lessons learned. And we have also a part where we have some more interaction. And the interaction will be that I will be talking and asking questions, let's say, to our panel members. And then also later we have an open part where it was Judah just said, let's say, that you are you can be engaged, and also people who are remote can also be engaged. Now, first of all, I'd like to introduce our panel members, which are also the leaders, let's say, of several of the virtual labs that we have developed. First of all, we have Patricia, Cabrera, and she is a scientific project data manager right now working at VLIZ in Belgium, the Flanders Institute. And also she has a scientific background in marine ecology and biodiversity data collection. So she's really, let's say, her virtual lab is really about the subject in which she is an expert. Then secondly, we have Jean-Olivier Irisson, and he is a computational ecologist. I really had to practice on this one. But he graduated from the École Normale Supérieure in Paris. And right now, since 2009, he is assistant professor at the Sorbonne University, especially in the Laboratoire d'Oceanographie, de Villefranche. And he leads the Plankton ecology team. And also they have a quite spectacular demonstrator based on this knowledge and this expertise. The third colleague in the team is Massimiliano Drudi. He is a researcher at the Ocean Prediction Applications Division of the CMCC, which is the Mediterranean Center for Monitoring and Forecasting. And they are partly involved in this Mediterranean Sea Monitoring and Forecasting Center, which is part of the EU Copernicus Marine Program. And he has a degree, a master degree in computer science engineering, and also a master degree in scientific computing. So you can say Massimiliano is very much from the computer side. At the same time, he is, I think, with his colleagues, he's now very much in oceanography and meteorology. So, and we have seen that also in the demonstrator. Then we have Anton Ellenbroek, and Anton, he will, in fact, tackle 2 virtual labs. In fact, he said by himself, he says 4, but we say 2, but he will explain that. Anton is, he works in the fishery department of the UN FAO, the Fishery Association Organization. And he assists the development of affordable data services in support of sustainable management of marine living resources. And he, let's say, he has been very much involved also in previous projects with web-based science, and especially in the domain of fisheries. And he will tell some also interesting items about the virtual lab. And finally, we have on the right, we have Pasquale Pagano, but we have to say Lino for those who are more intimate with him. Because in the beginning I was asking where is Lino, and he said he's sitting in front of you, but it was Pasquale, but that happened. But Lino is he's the technical director of D4Science, which is a CNR data infrastructure, and which is in fact let's say the core platform for our virtual research environment. And he is also the infrastructure manager of the Big Data infrastructure, and he is also a chief manager of the G-Group software. But I would say to summarize, Pasquale is our I would say our tech wizard. He can arrange the virtual research platform, and of course with his team, he's not doing it alone. But also he is providing the computing resources and the storage resources, etc., that we need to host and to deploy the platforms and the virtual lab. And in this way, he is also indispensable, like all the others in the team, because it's really a group cooperation. And we have scientists, and we have computer specialists, and we have data management specialists. So we have, and we also have, of course, outreach specialists. We have business exploitation specialists. We have really all the flavors in the team that are necessary to make such a project a success. Not only a short-time success, but also a long-term success, because you need to build out this perspective. Okay, enough said. I would like to start myself, with giving a technical overview of the Blue-Cloud. And let's see if I can do that with the... And I have 10 minutes left, so I am start. Yeah, okay. So this is about exploring and demonstrating the potential of the Blue-Cloud for ocean sustainability. And first of all, I have to come back a little bit, let's say, to the setting, the context. We have the so-called, we acquire a lot of data over time for many different applications. Of course, science is something, but also for management, for governance, for industry, for underpinning all the directives and the conventions. And we already heard, of course, from our colleagues from the European Parliament and the EU officer, let's say, that framework, and also from Sara. And that means that we are acquiring a lot of data. And over time, let's say we did an assessment as part of EMONET. And in EMONET, we estimated, together with the survey, that we spent about 1.4 billion euro per year in Europe on collecting data from the sea. And of course, collecting it with many different means. Underwater, on the water, above the water, in the soil, etc., in the seabed, everywhere. And that means that about 1 billion is in situ data gathering, and 1.4 is, let's say, remote sensing, especially the Sentinel program, of course, the missions. And that means that if you are collecting so much data, you also need, of course, good means to manage all this data, because otherwise this money would not be wisely spent. And for that reason, we have built up over time a very good European landscape of marine data management. And that landscape, you see it here, say, in the schedule on the site. Oh, yeah. Julia, can we also do the central screen on the presentation? Okay, because it's everybody looks in the corner. Yeah. Okay, but anyway, we have this layer. So we have, let's say, first of all, the collection layer, as I just illustrated, and then we have the aggregation level, where we have 3 major infrastructures. One is SeaDataNet, another one is EWODNet, another one is Copernicus. And if you look a little bit at the details, let's say SeaDataNet is this network of national oceanographic data centers, and they try to get in, let's say, most of the data coming from cruises and also from other operational activities, and making long-term stewardship and also making higher quality data sets to be used by many. Ah, it works. Yeah, you see. Okay, good. Technology, guys. Then we have EWODNet. EWODNet is one step higher. Let's say in EWODNet, they use a lot of the data from all these different sources to produce very good generic products and services, which are then, let's say, serving many end users, but also, of course, again, I call the middle users, let's say those who use products to add value to them for other purposes. And that could also be a lot of consultants from industry, but of course also scientists. So in that sense, EWODNet has developed over the last 12 years into a powerhouse, I would say, with very good products and very good use statistics. And that's all, at the same time, it's only possible because the data flow is very good and it's getting larger and larger. And that's part of our proof of the pudding is in the eating, of course, that we try to demonstrate. Then we have Copernicus. Copernicus is also a large program. It's related to the, let's say, the satellite program, of course, the Sentinel, but also doing more with those data, and then in combination with in situ, and generating large climatologies, but also generating forecasting products. And also Copernicus is now more than 10 years on the road, and it's also very successful with a lot of users, a lot of, I would say, a lot of indispensable use applications. But there is more, of course, because these are 3 of these major initiatives. But there is more because there are many different, high variety of data types in the marine domain, in the ocean domain. So we have a lot in the biology and bathymetry. We have genomics. We have, let's say, many different flavors than only the chemistry and the physics. And that's why we have also, and geology, so that's why we have also other organizations which are mostly research infrastructures, according to the ESFRI definition, but also others that have not yet that definition, but are a real European infrastructure. And they bring together all this data, and that means that we have all these data aggregators, and they provide data products and services. And that was, in fact, for us, the landscape that we saw, and that we said, hey, we can do more. We can do more integration, and we can also do more, bring the data to a higher knowledge level. And that started with the Blue-Cloud project, reacting to a call from the Commission based upon the G7 Future of the Ocean and Seas initiative. And in fact, the idea is to explore and demonstrate the potential of cloud-based open science, supporting research for ocean sustainability and the UN Decade of the Oceans and the G7 Future of the Ocean goals. And therefore, we developed a cyber platform with the Smart Federation. And the federation concerns multidisciplinary data, it concerns algorithms, and it also concerns, let's say, resources for computing and storage, and for publishing, of course. And also at the same time, we looked with another eye, not only to the marine community, but also to the European Open Science Cloud developments. And then we say we can also be a role model, a blueprint for a marine thematic European Open Science Cloud. And this way also share our experiences, but also learn, of course, from the EOSC developments. And this way have a close synergy and a close win-win. And that's also, I would say, is paying off because we see many marine thematics now also in the EOSC. And also we see a lot of sharing of experiences about federation and so on, and sustainability and so on, let's say, with EOSC. The overarching concept is that, first of all, we have the upstream. That means that we try to bring give better access discovery to all those different resources that we have seen, those repositories and data holding organizations. Then if you can harmonize that more, then you have, let's say, you use standards, and those are open standards, like the OGC, the ISO, W3C, but also vocabularies and also, let's say, profiles of standards. And then on the top, we have the virtual research environment where we use all this, let's say, better access to data to make applications and to feed it into applications that then create more information and knowledge. So these are, let's say, the parties in the Blue Cloud, the initial Blue Cloud. So on the left, you see these so-called blue data infrastructures. So you recognize most of them from this European landscape. And on the right, we have the computing platform, which is D4Science as the core platform. And Lino will tell us more about that later. And then we have Vecchio, which is, let's say, the platform from Copernicus Marine, where you can find the Sentinel data, but also computing and processing power. And there is the UDAT network. And also, let's say, the D4Science works together with EGI. And EGI is now in the successor project, let's say, a full partner, while in this case it was more an associate partner. So we have the key products. We have three types. First of all, there is the Data Discovery and Access Service, so a federation, giving common access to the different infrastructures. Then there is the virtual research environment, and on top of the virtual research environment, there are the virtual labs, each for different multidisciplinary challenges, and they all will present themselves. I will go a little bit deeper in this discovery service. In fact, you see here on the top, you see the repositories which are which are being federated. And what we do is that we do it in a two-step approach. In fact, let's see it. Goes. Yeah. Oh, sorry. Now, can I go back here also? This one. Yeah. Yeah. Just the illustration, let's say, of the different types of data that we have. So just it's all global, you can say. And it goes from chemistry, biology, physics, genomics, microscopic taxonomy, whatever. We have a lot of different data sets. And in total right now it's about 10 million entries, let's say units, you would say, at the lowest level. Then we have this conceptual approach that we do it in a two-step approach. So first of all, we look at aggregated collections, which means that the number of data sets is not so high, only 25,000 currently from those 10 million. There you do a common search with a common metadata profile on some common criteria, like space, time, subject. And then when you know which of those infrastructures contains something that's interesting for you, then you can drill down and add some more search criteria by which you're able to find your goal and what you really want to have. And then you can download that remaining set. And that's illustrated here. So this is, let's say, the main screen. So first we find a number of we get an answer which has the interesting data sets, in this case EuroArgo, and then I go a little bit deeper in EuroArgo. I see here the collections of EuroArgo, and then I go a little bit down to drill down to more specific cycles, as they call them, and there are more than 3 million cycles. And then we get let's say, the display of those cycles, and then you can individually say, these are the ones that I want for my subject. And you can do that in a shopping basket, which is then, say, also you can combine it with data from other observatories in the same way. And everything is open access, so you can download everything. To build this, we are confronted with many different protocols, let's say, for the discovery and the access. And that's a little bit shown here. And one of the challenges for the next step will be, let's say, to harmonize a little bit more the functionality between these different so because in this case, we did a lot of what I always call plumbing. It means that we try to fit all pipes together. But of course, to make it more fair, it would be nice if you have more common functionality that we can support with different technologies, always. Then the virtual research environment, that don't go too far, but this is a collaborative platform. Lino will go deeper. We have 5 virtual labs, and each of my colleagues will present those, also somewhat deeper. So I come now to the conclusions. I have 1 minute left, so I'm right on the spot. Now, the first one I don't have to explain, of course. That's already being told by Pierre Karleskind from the European Parliament, and also underpinned by Nicolas. What we have seen in the project is the fact that the federation of the blue data infrastructures, it really works. It's feasible. It works. But of course we can do better, and like I said, for that we can do some more steps, which is harmonizing a little bit more the functionality, but also adding what we call data subsetting. That means that you not only search on metadata, but that you also can search at the level of data. So let's say I want all the temperature at 20, higher than 20 degrees and below 500 meter depth, something like this. I don't think there's many, but this example. but that's the way to look at it. Then we have, we're also seeing that the modular architecture of the VRE is scalable and sustainable. And also it has been proven to be fit also to connect other e-infrastructures like EGI, like UDOT, like Wikio. And also it means that we can also bring on board more advanced services, and we can also connect to other e-infrastructures that are supporting other advanced services. And that's, of course, that's the way also to federate and to make use of the other, I would say, the other energies that are already being displayed and being deployed. And also we were able to reach out to a large group of researchers that really successfully were able to use the tools. That's also important. Not only the people in the project, but also invited synergy projects and other researchers were able to work with it. Especially during a hackathon, this was demonstrated in a good way. Finally, the pilot Blue-Cloud has confirmed that the EU marine community is also ready for this, and they are aware of the Blue-Cloud initiative, but they're also ready for this, and they want to, and they are recognizing the potential. And that means that we can prolong this and we can advance this and also play then a role in accelerating the knowledge and the science-based solutions to aquatic science and challenges. And that's in fact, it's exactly the DTO. Let's say the DTO is on the horizon. But of course it's not only the DTO, because it seems now we have only a DTO, but we must see it in a wider perspective that there is a large community in governance, in science, in industry and in citizens that want to be better informed and want to know more. And to be able to reach out to them and give them also tools and services, let's say the Blue-Cloud, but also together with AMODnet, together with Copernicus Marine, together with EOSC, is the way, let's say, to reach out. And then the DTO is the cherry on the cake, I would say, which allows you to do these what-if scenarios, on-demand modeling and giving answers. And, but they should still realize, of course, that the DTO is only possible by supporting and sustaining the underlying foundations, because without those foundations, there will be no cherry on the cake. There is no cake then. Okay, thanks. That's my final presentation. And now I want to give the word to Patricia to start with the VLAB and to keep us on the schedule. You can reach.
Well, yeah, can you hear me well? How do you do this? The green one.
The big one. The big green.
Okay. Okay, good morning, everyone. My name is Patricia Martin Cabrera. I work for the Flanders Marine Institute here in Belgium, and I will present you the zoo and phytoplankton essential ocean variables demonstrator, which has been developed by an expert team of researchers from the Laboratoire Observatoire sur Villafranche, de Villafranche-sur-Mer, and our colleagues from ULIES and the research division in VLIZ. Oh. Okay, so the objective of this demonstrator was to derive zoo and phytoplankton biomass and diversity products based on a machine learning approach. So for this, we compiled and processed large-scale set of plankton data, and then we applied big data machine learning methods such as neural networks, and then these products were validated with near real-time data. So all this is now presented in the Blue-Cloud Virtual Research Environment, or VRE, where we have made use of the different services such as the Jupyter Hub. So this demonstrator consists on 3 parts. The first one is the phytoplankton EOFs, and this is built by a series of input data that you see now in the screen. So these are in situ observations matched up with satellite products from ocean color or sea level anomaly. And then there is a neural network model applied, developed by Zauzade, and this is presented, it can be run in the Jupyter Hub, it's written in Python, but it can be easily run by non-programming experts. The output are 2. First, we have global 3D maps of chlorophyll A at different interval depths, as you can see, the map moving. and this is a proxy of phytoplankton biomass. Another output is a second neural network using pigment data was applied, and these derive, again, global 3D maps, but at different phytoplankton groups, size groups, from smaller to bigger, you see, from pico to micro. And here we have an example of the output for January, winter, and June, summer, with a typical austral bloom on the southern poles. Then the second part of the demonstrator is the zooplankton essential ozone variable products. This was developed by our colleagues from ULIES, and here we used zooplankton abundances accessible from EMONET, one of the blue data infrastructures in EMONET biology, and combined with environmental data from other blue data infrastructures, just SeaDataNet. And then here there was an interpolation method and a neural network model applied, which derived gridded zooplankton abundance maps in the Northeast Atlantic. So this is again all developed and integrated in the virtual research environment in Jupyter Hub. So there are Jupyter notebooks that anyone can run and get these outputs, and as well reproduce with other data. This is written in Julia, but you don't need to be a programmer in Julia to run this. So here in these maps, we have on the left plots the in situ observations, and after applying the neural network model, we can observe how we have a more smoothed gridded map. And this was done for 6 of the most abundant copepod species in the Northeast Atlantic. And the final product was a modeling phyto and zooplankton interactions developed by VLIZ, where we use phyto and zooplankton abundances together with environmental data to apply the NPZ model, nutrient phytoplankton zooplankton model, to understand what are the drivers, the most important drivers that give us the phytoplankton abundances. This is one of the outputs where we see the relative contribution of each of the drivers for phytoplankton abundance. And just as a lesson learned after these 3 years working on this demonstrator, so open science frameworks such as Blue-Cloud enables non-programming experts to reuse and reproduce these methods, as we have experienced in our Blue-Cloud hackathon. We had users using our demonstrator with other data and creating new products. As well, the integration of different data sources from the different BDIs and technologies in the virtual research environment allowed to see data-driven trends and to understand the essential ozone variables. And finally, a collaborative virtual research environment have a large potential to boost scientific productivity, and we invite everyone to explore the data, methodologies, and technologies available in our demonstrator. Thank you. So I give the floor to Jean-Olivier.
Okay. I'll just do this. Or not. Yes. Hello, everyone. So I am Jean-Olivier Irisson, but what I'm going to present is a team effort of people at Sorbonne University and EMBL EBI, chief among which is the first author, who is Alexandre, who is actually in the room. So everything that I'm going to present is a lot of his work, so he should get the laurels, basically. So we start with plankton genomics from the Tara Oceans initiative, and that means roughly 100-something stations where water was collected all around the world. Okay. And then at these stations, the material was sequenced, and you start with a lot of small fragments of DNA. Oh, that works there. Small fragments of DNA. And the first step was to assemble those fragments of DNA into genomes. So it's virtual genomes that are called SMAGs, okay? And what I want to prove with this complex graph is that basically it covers a lot of the tree of life, okay? And it's a lot of data. In the end, the assembly is 10 million genes. Then, to summarize this, what we did as part of Blue-Cloud was create what's called a sequence similarity network. So basically, you assemble the genes based on how how similar they are based on their sequence, and then you decide on some thresholds, and that makes small clusters of genes that are really similar to one another. Okay. From 10 million genes, we got to 1.2 million clusters, and then in each of these clusters, each gene is taxonomically and functionally annotated. That means that we say to which organism it belongs and which function it relates to. What's important is that at this stage, there's 50% of the genes roughly, or it depends on, but a large proportion of the genes where we don't know. Okay, we don't know to which taxon they belong, and we don't know what they are used for. Okay. Then we have 100-something station over the Earth, and what we want is a global map. Okay, we want to interpolate, to extrapolate everywhere. So to do this, we use this process where some pieces are missing, but basically we start from a place where we have the information about the abundance of that gene, and then we assume that this gene is carried by an organism, and that organism depends on its environment. So it's not present everywhere; it's present where its environment is favorable. So we look where, what the value of the environment is, in that case temperature, and we say, well, we can draw that curve where we basically see that this organism is rather liking warm temperatures. And that means that once we have that curve, then we can take another place on the Earth where we did not go with Sara, and then figure out what the abundance of the organism could be there. Okay? So except we did not do it for the organism, we actually did it for the genes in that case, or the clusters of genes. And my nice font. It was not that one. So we did it in multivariate way, meaning that we have several genes as input and we have several predictors. It's not just temperature. Okay? So the complex schematic of what we did is here. We have many genes. We have several stations. We have a multivariate modeling tool in the middle. And in the end, we have several maps of the potential distribution of that genetic material over the whole ocean. And also what I want to point out is that not only do we have the map of the potential distribution, we also have an uncertainty of that map. Okay, and now I'm going to rush through one application which we did. We looked at carbon fixation in small algae, 0.2 to 5 micrometers. So genomics is really the only way to study them. There's two different ways that carbon can enter in these cells, the C3 and the C4 cycle. And what you have on the right is basically maps of the enzymes along that cycle. The general, So the general takeaway from this is that basically the C4 cycle, what you see here is that it's potentially everywhere in the tropics, okay? And on the right, it's mediated by where the organisms actually are, and we see some differences. So basically, the genetic potential for some functions is everywhere, but it's actually modulated by the organisms, so these organisms still matter very much. So in the end, or lessons learned for the future, basically, we used 300 clusters among the 1.2 million. That's 0.02% of the data set, of one genomic data set. So there's plenty of work for others to apply the same thing to other functions of these organisms. And it was the first implementation of the multivariate modeling tool. It was the first implementation of this niche modeling approach for genomic in the cloud. So of course, there's something to improve. It can be faster. It can be more efficient. It can be applied to more data. And the good thing is that the postdoc, Alexandre, who is here with us today, who spent 3 years learning how to do this, will continue with us for Blue-Cloud 2026 in a different lab with other people. So we hope to carry that over to more data types in the future.
Good morning. So my name is Massimiliano, and I will present you this service, Marine Environmental Indicators, that is coming from the collaboration with other partners, me from CMCC Foundation, then there is also IFREMER, KNMI, University of Bergen, and Mercator Ocean International in this partnership for this service. So in this service, we are addressing objectives that are stated in different international initiatives. And in this scope, basically, we are developing a decision support system for agencies and stakeholders in the environment protection field. And indeed, users can exploit this service for the analysis of marine area, and for instance, to assess the good environmental status of a region or predict undesired changes that might happen in the future, and in case take actions. So the methodology behind the work that we have done, first of all, a scientific approach is used, starting from the algorithms that have been developed and implemented, and then shared with the Jupyter notebooks. Then after that, the second important step is the transition of those algorithms from the research to the production environment. And to facilitate this delicate activity, we did some specific work, for instance, on the specifications for the interoperability, then also on the software toolkit for the implementation of the many common functionalities that are needed. And finally, on the developers' guidelines to assist this whole process. Finally, the last step is the deploy on production, and this is we are doing this on D4 Science, that is the infrastructure providing the computational resources. And in addition to that, the service relies also on other important infrastructures, new infrastructures for the data provisioning. And for instance, we are using the Copernicus Climate Change Service, the Copernicus Marine Service, AeroArgo, Amonet, and IGOS Marine. The service workflow starts from clearly from research products that are published from the previous mentioned infrastructures. Currently, local copy of subsets are available to provide the input to the processing. And then a web user interface was developed to allow the easy exploitation of the multiple available input data source and multiple available algorithms. And indeed, this interface is implementing several functionalities to calculate and distribute the environmental information and indicators as they are generated from the algorithms. And those are the outputs that actually we need and we want to have. What are the algorithms? So the service is including 4 algorithms now. Ocean climate indicator that can be used to generate ocean characteristics and statistical indicator for different variables and time ranges. Then ocean patterns and regime indicators that is using a machine learning methodology to classify ocean profiles and time series, and to identify space and time coherences. Simple access to carbon data is a service which is offering a very convenient way to access carbon data and harmonize formats from different infrastructures. And finally, storm severity index that can be used to identify exceptional wind circumstances on different time scales. And that's all for a short introduction of this demonstrator.
How do I go forward?
The green.
This one?
Yeah.
Okay. Well, good morning, everybody. My name is Anton Ellenbroek. I work in the Blue-Cloud project, but I also work with FAO of the UN. We are based in Rome. We are a UN organization. We think, we talk, and we work to achieve the SDG, Sustainable Development Goals. So we are in this project to help us organize our data better in the fisheries and aquaculture domain to make products that are useful for people around the planet, so not only in Europe, but we have a global vision. And we try to work with the Blue-Cloud team here also towards the future to make sure that also people in developing countries have access to European developed infrastructures and computing resources. So in Seashell, so the lessons learned in this project, these are a few names of the people that contributed to the success so that we have now in the Blue-Cloud with the fisheries and aquaculture demonstrators. They're all very angry at me, I think, because I knocked out all their slides from the presentations to make sure that we only had 12 slides in the presentation set of the original 30. But you see they are based not only in FAO in Rome, we work with Forth, they are based in Greece. We work with IRD, sometimes based in France, we're usually flying all across the planet. We work with CLS present here. And we have a lot of in-kind contributions. So I have to say this activity in Blue-Cloud is not only using Blue-Cloud resources, we had a lot of FAO effort to make the demonstrators really work and to also get a community feedback, community collaboration, and a real community of practice that developed all the tools that you will see now, the results. So we start with the last one, D5, the Aquaculture Monitor. So they were always the last in all the presentations so far, so I thought let's move them before the fisheries one for once. And there the goal was to have satellite monitoring of aquaculture locations. So there was an analysis of the technical feasibility that relies on the type of satellite data that you can access and use for your analysis. So we work with a synthetic aperture radar that works day and night, is all-weather radar, is available through the Copernicus, and basically works everywhere. But then sometimes we want to go a step further. We need some more information. So there we need medium to very high resolution optical imagery. That is very weather sensitive, so we had to be careful and develop our test cases a bit more for what we thought was feasible with those weather sensitive data. Then the affordability relies on the use of open satellite data from the European Union Copernicus program. So the Sentinel constellation is like a great resource for free satellite data. But sometimes you need a bit more, but then you run immediately into the issue of cost. So images from commercial satellites, truly expensive. So where do we find then an effective collaboration between free satellite data and more paid for services? So we use this service really to focus on where can we detect aquaculture, and then the next step would be what can we monitor then with more expensive commercial data. So this is really an experiment to try to find an overlap, a workflow from free data to then identify cases where you might need an extra mile or an extra step. So the objectives we had was to detect cages, floating cages in the ocean. You've seen already a few nice images developed in the Seascape rolling presentation with Sentinel-1 radar imagery, and we had a few focus areas. You'll see it later. And then the next one was to use some artificial intelligence to detect, so you can see detect a typo there, to detect coastal aquaculture with Sentinel-2 optical imagery, and there we had a use case in Indonesia with a very good collaboration with an Indonesian colleague who really helped us to validate what we had produced. So the results, well, a few images, always nice. We were very successful in detect aquaculture clusters, so cages floating, they had to be like 9 meters in tall, wide, etc. They had to be square or round. So we really developed a service. CLS developed a service. The Blue-Cloud took the results, so we really have an interoperable environment now where you can see the aquaculture clusters either in Chile, and we also did the same over Tunisia where you can detect the clusters, and we validated with those results, and the results are quite good. So we get a 76% precision, and in Monastir, where it's less cloudy and the weather is nicer and the cages are not bobbing around so much because the ocean is flatter, you get an even higher precision for detection of cages. So this is very useful information if you need to manage aquaculture. You want to know where your cages are. This is a very cost-effective way to find exactly the geospatial distribution of your cages. The inland aquaculture, so the objective there was to use artificial intelligence to assign land types. And then the land types we were, of course, interested in were the aquaculture ponds and other crops. So an aquaculture pond looks very similar. Thank you. 5 minutes, that's good. I'll make it. So you detect aquaculture ponds. So sometimes an aquaculture pond looks very similar to a paddy field, but we managed to detect the difference. So the results, ground-based validation with an Indonesian partner, INRIA. That person has a lot of geospatial information. And there we have a similar good accuracy of 71.6% to detect aquaculture ponds from and differentiate that from other types of land use. So now that was the aquaculture activity, the monitoring of aquaculture. Now the Fisheries Atlas, which is a collaboration between FAO, IID and Forth in the Blue-Cloud, but also with engagement from academia, the University of Washington. It has a huge knowledge base on fisheries and stocks and fisheries. And also now with an uptake by industry, Sustainable Fisheries Partnership now works already with industry to see how they can use these identifiers that we have on stocks and fisheries and to bring those into even on the labels of products. And also Carl Presser here with the Food Cloud, he should follow that activity. So the results are a global tuna atlas and a global record of stocks and fisheries. The global record of stocks and fisheries, so these we brought 4 very different sources together. It's a years-long work, many activities. And there you see the results. It is a global map, but you can click on each stock and you can see a lot of information provided by very different organizations. And we managed to get it all together in one knowledge base. So now we have more than 2026 approved records. So you know the number 2026, that is your next project. We will be there not as FAO, but our partner Forth will continue this activity in the next phase of the Blue-Cloud. So we have the catalog, the map viewer, and web service, confidence queries, a Sparkle, etc. That gives you a lot of information that allows you to trace stocks and fisheries along the value chain, all the way down to individual products in theory. The Global Tuna Atlas, next one. This builds on open source tools where we delivered the fisheries, the Tuna Atlas, which is online now in the FAO domain. You see that it is already accessible. It's based on data provided by the 5 big tuna fisheries organizations that you can now access through either an interactive map viewer or through a metadata catalog. You see we have a comprehensive view of how do you manage data. It should not only be going in one direction. We try to disseminate as much as open and well-cataloged data through a variety of outputs. So this is then the fairy tale. So how do we get all this stuff into FAIR? So we really work to be compliant with the standards to foster interoperability. We will have discovery of metadata services based on Dublin Core and DataSite. We have a lot of usage metadata that we collect along the value chain. And then we add a lot of domain-specific metadata, so coming from the fisheries domain, for spatial temporal, but also gears and whatever you can see on the boat. And then we display these in automated dynamic reports with R Markdown or Shiny App. So at the bottom you see a few of what we see as then a chain of custody for this data. And then we execute all that in a virtual research environment. And we really think in FAO that virtual research environments are very useful. They are focused. You can get your application up and running in like no time with Lino here. And then it is hosted in the D4Science infrastructure in the general context of EOSC. And VRE consists for us usually of widely used software. So you see at the bottom, you see this whole chain of services where one builds upon the other. And as the known problem with chains is one link breaks, the whole chain breaks. So this is really a matter of caution. If you develop something with a VRE, have a long-term perspective, think about how you maintain it, how you develop it, but also how you use it and how you can work with. I'm less than 1 minute. This is my last slide. Well, yeah, you're even worse than Dick. So think about to have your stuff ready before you ask for a VRE, because it is complex, it is complicated, and it is sometimes frustrating. But it really helps us now to reach a global community where we have trained more than 1,000 people on the use, for instance, of fishery stock assessment models in a VRE. Okay. I find some. Oh.
Good morning, everyone. I'm Pasquale Pagano from the National Research Council in Italy, and I'm going to present, how the Blue-Cloud virtual research environment support, the communities in their phase of developing and, a virtual laboratory. Let me say that it's a pleasure to be here. First of all, before to start, it's a pleasure to meet, a lot of old friends, but it's also a pleasure to see a lot of new faces. And it's a pleasure because our mandate is to support science. And to support science in Blue-Cloud, we need scientists. We need, to enlarge our community and to make, this environment that is open access, exploited by other, communities, by other groups of researchers. So it's a really pleasure, to make this presentation to you all and to show what we deliver to our scientists, to our communities, to improve, the way they do their job. So let me start with, just few, a synthetic way. We say that, the Blue-Cloud VRE is just one place to perform data discovery and access, one place to store, share, and preserve any of your research product, not only the data sets, but also your software code, the products that you generate, all the material that you use, in your scientific activity. And clearly, it's also one place to execute and perform data analytics. How we build, this system? It's clearly, we rely on cloud technology. But we decided to build as a system of systems. This means that we integrate, services that are provided by many providers. That it was mentioned, one of the core part of the platform is represented by D4Science, that I know quite well. But it's not only the only provider. We use services that are operated and maintained, by EGI, for example, as part of the EOSC agreement. We support, we integrate services provided by others. And altogether, we made this platform that then is used by the communities and is exploited by the different virtual laboratories. And this platform is not closed. It's extensible. So we integrate the services provided, for example, by FAO. We integrate the services provided by the community itself, but we operate, with the same quality of service as all the other core services of the platform. And then, in everything that we do, when we perform integration of technology, we try to push towards, open science. And open science is not only open access, but is to support, all the life cycle of the science. So starting from, letting people to store, to access, to discover and access data, then to store, to share their code, to share, the way they use their code. The parameters that were used, to execute, a process in the Blue-Cloud VRE. And everything that we do is to enable, the capability to repeat, to reproduce, to reuse, and to evaluate, the results of an experiment, in this way, to stimulate active collaboration, sharing, and to do these, we automatically collect, the provenance information. So all the operation that the scientists perform on the platform is accounted in such a way that it can be reused by another scientist. And this is done by using as a service approach from a technical point of view, using the standards, as Dick said, and we make economy of scale to make this platform, sustainable and affordable from the operational cost. This was, introduced by Dick. So it's one place for access. As you have seen, we have integrated in the Blue-Cloud VRE the Discover and Access service. And this allows to retrieve data sets and to, first of all, to discover, to put in a basket, to retrieve, oh, sorry, too fast. And then, to push back either to download or to push in the Blue-Cloud VRE. And clearly, if you need to process this data, you have one common environment where you start, collecting your data sets. You have, then in the cloud, and you can elaborate and perform your analysis by registering your software also in the cloud. We deliver a common storage that we call, not just one, let me say, one version of storage. We integrate several technologies, and we deliver what we call, workspace and data space. There are two different systems that allow to use the cloud storage in easy way. This storage is fault tolerant. We support automatic encryption, automatic compression and decompression. And clearly is fully replicated. It automatically supports versioning in such a way that you can save, several versions of your data sets, and you can reuse, a previous version. It automatically generates provenance, and it allows to share, according to your policy, the data with your colleagues. As I said, there are different types of storage with the different technical characteristics, and in such a way that the community can use, the one that is better fit, the needs. For example, the data space is very fast. We deliver 1 terabyte, to the community, to perform, the storage of their data. But this volume, for example, is not encrypted or is not compressed. It's just to support data analytics. If you want to store and preserve your data, it's better, for example, to use the workspace instead. That is much more efficient in this sense. And then we deliver, also one environment to perform analytics. Again, not a single service, but a combination of them that were identified thanks to the, to the discussion with the community. So clearly, the notebooks, an environment that is called RStudio, and also, an high-throughput computing platform that allow you to perform your jobs in a distributed fashion. By using these core facilities, then the communities, as you have seen, our colleagues in the project develop, the 5 virtual laboratories, and each of these virtual laboratories, as you have seen, implementing, several services. In total, at the end of the project, we have 13 services with a very, let me say, high TRL at the end, that we registered in the EOSC marketplace also. But Blue-Cloud was also used by other research infrastructures and projects, outside the consortium. We are building, let me say, a strong agreement with Jericho. They are already exploiting, what we deliver in the Blue-Cloud VRE, and we also support, Jonas, as 2 examples of external collaboration that already use what the Blue-Cloud VRE is delivering. So finally, this is my last slide. It's just one common place. And when we say we support collaboration, it's not just a way to exchange messages or to talk together, but it's a way to exchange all the research products. So it's a way to work, with the scientists, delivering, what they need. So for doing this, we support sharing, we enable reuse, and we enable, the reproducibility of what is delivered through the Blue-Cloud VRE. And yeah, this is my last slide. So thank you.
Yes, it's working. Yeah. Okay, then we go to more questions and answers. So this part of the panel where I have a number of questions for our colleagues. And let's say it takes about 15 minutes, 20 minutes. And after that, let's say we open the floor also for others in the room or also a remote that would like to have questions. For remote, use the Slido. And for of course, in the room, use the microphone that you found in your chair. I hope you found it by now. Okay, let's see. Patricia, I think I start with you, because you were also the first field lab that was presented. And could you say what was your biggest challenge that you so far, let's say, experienced in this field lab development?
Well, can you hear me? Yeah. I think one of the biggest challenge, because there was a few, but was to work to develop the demonstrator, to do all the research in one side, and to work and to integrate all in the virtual research environment, which was shaping at the same time. Yeah. So I think it was, at the beginning, was very challenging. I feel like researchers are more used to work in their own computers and have fears to go into the cloud. But once we were there, I guess, yeah, during the first 6 months, we set up the VLabs, we started using the services and including everything that we were needed with the help of Lino and his team. And once we were there, we actually found a lot of benefits. For instance, there was some really heavy computations in one of the models we were using in RStudio. And from using it in our local machine, it took, there was some part calibrating the model that we had to run something that was taking hours, like a day or something in our own machine, and we reduce this time to like 20 minutes by using in the RStudio and the parallel computing in R. So yeah, I think that was something we learned, that it was very important that we work together with VRE developers as more functionalities were needed. They were giving it to us. We were really trying to understand what was all those services, the software importer, yeah. So I think that was it.
Yeah. No, quite clear. I think, of course, that's an experience that most of the field labs had. I'll say that you start the project, and then the platform is basically ready, but not ready enough. And people have to learn, have to have an uptake process, and on the other side, they already have to work on the specifications. And that also means, of course, I think in your case, let's say, and also the others, that if we continue this work, we have now much more ready at use, and we can build upon from there. Let's say make a big jump forward. I have a question then for Jean-Olivier. You are using right now, let's say your field lab is really based upon genomic data set and a static data set. But of course, there is a lot of growing quantity, I would say, of genetic data sets being produced. And I always heard from DNA sequencers, they can produce enormous amounts of, you already gave some impressive numbers there. But how far you think are we from being able to exploit all this data? Because it's quite a challenge, I think, also in computing, but also simply in human handling and scientifically handling.
Okay.
Sure.
Hello? Yes, that works. So indeed, we start from something that has been processed. And so basically in the EU, we have the European Nucleotide Archive, where we have the raw reads, so the bits of sequences, okay? And as I've shown in the slide, between the bits of sequences and the input of the model that extrapolates it, there's a lot of work. You have to assemble the genes, you have to annotate them, etc. So the good news is that there's pipelines that already exist for some of this. And so the challenge will be connecting those together so that in an ideal future world, we can say, okay, I'm interested in this, and then the raw data is fetched, it's assembled, it's annotated, and then we get the result. There's technical challenges in connecting these different data sources. There's computing challenges also, because we're talking about 100,000 hours of CPU time. Mm-hmm. And so it's not in a single place. It will have to be spread across the resources. So I think it's these two, and then indeed, when you read the papers, there's a lot of manually curated data in the middle. So there's for some of it currently there's the need for an iterative process between the scientists and the data. So it's some pieces cannot at present be fully automated. So there will be another challenge to, how do we stop the process, ask the human to give the feedback, and then continue the process afterwards. The good news is that at least part of this is the plan for Blue-Cloud 2026.
Okay, thank you. Yeah. Now then I have a question for Massimiliano. Let's say Massimiliano showed us, let's say, the environmental indicators. And so far you've been focusing on the Mediterranean, as we also clearly could see in the images. How do you plan to go wider, let's say, global aspirations? And what would that mean for computing resources and the process that you are dealing with right now?
Yeah, so at the beginning we were focusing on the Mediterranean domain, and that's right. Clearly the objective is to work on the global domain and as well on any other region on which a user might be interested. And this is already possible. The implementation is already allowing the selection of the domain of interest and the several algorithms. For the several algorithms, it is possible to choose exactly what is the working domain and continuing the processing on that area. Well, now to improve again, there are several. I guess there are several aspects to take under considerations. The first is improving, for instance, the access to the input data. That is an important, the beginning of the first step before starting the processing, and now it's still a bottleneck for this implementation. And during this project, we had the chance to see the new data delivery and the data access service that has been developed in Blue-Cloud, and there will be more developments in the new project. So I guess there will be room for further improvements and find a solution that can also underpin this kind of application that has the particularity to need. So the idea is to have an interactive solution for the analysis and visualization of marine big data. So everything in the chain must work with very good performance. So that's the first step. The second step is the good access to the processing computational resources, and also in this case, I guess we need time to find a proper solution, going step by step and understand step by step what is capable with the current available solutions, and understand what is needed to improve again in the future. So it's an iterative process that needs projects for the development, and I am pretty sure there will be room in Blue-Cloud 2026 to go further. So I look forward for the continuing of the project.
Yep. No, clear. So it's all going bigger, wider, faster. That's in fact the keywords that we are looking for. And it's not so easy. It sounds easy, but it's not easy, because you need a lot of resources, but you also need a lot of understanding, of course, how to apply it. And a lot of, let's say, management to be able to really make optimal use of these. Then we have a question for Anton. Anton, Anton in fact demonstrated, let's say, 4 different products. In fact, all fisheries related. But can you say something maybe more general about the international context, let's say, of what you were doing? You already spoke a little bit about this, but how are you exploiting this, let's say, on the wider global scale, the products that demonstrate?
Well, I can talk here, but then the lady with 1 minute word will come up again.
No, you have to do it in a comprised way, as you did before.
Oh, no, so just a few numbers. So there's 100 million fishes on the planet, and half of them are women, so at least related in lots of them in processing. So we also have to, if you talk about in international context, how massive fisheries are and aquaculture. So it's the most widely traded commodity in food and agriculture. So it is a real big issue, and a lot of people involved, engaged, and they all have to give them some safe and sustainable livelihoods. You really have to think how to support them, and also with maybe some online tools. So maybe of these 100 million people, quite a few already have a mobile phone, so that we have ways to communicate with them. But they also need a lot of new capacity to manage what they have in their waters. So either aquaculture or inland fisheries, marine fisheries. So they're all big sectors. A lot of people involved, but how do you build the capacity for in those countries outside Europe to manage their own resources? So we think with the Blue-Cloud we have done some very good work. We have trained more than 1,000 people. We have people very active also in Tanzania that really train people on how do you analyze your time series of your fisheries, etc. How do you combine data from different countries together, so a more regional approach rather than only a country approach. But how do we continue this? And I think we need an infrastructure where we can rely on that allows us to bring the tools that we already have, lots of the tools in R or Java or other software. We just want to be able to drop them in a VRE, and thanks with Blue-Cloud and DeFi-Science, we've gone much farther than where we were like 2 or 3 years ago. So this is short enough.
Yeah, perfect.
Oh yeah, she's still there. Yeah. No, you were reaching already.
No.
But that is a seal that you have.
Yeah, Anton is not used to time management.
Time is on my side.
But he has a lot of intelligent knowledge to bring. Then I have a question for Lino, because Lino, you've shown, let's say, the virtual research environment and also how it works together and how bringing all these resources together, especially computing and storage and applications. Also, we talked at the beginning, I showed a little bit, let's say, that we are a blueprint for the European Open Science Cloud. So you can say the Blue-Cloud is a marine thematic model for the EOSC. Could you explain that a little bit from your perspective? So you are closer to the e-infrastructure community, I would say.
Yeah. Okay. Thanks, Dick. So, I mean, this question, let me explain a bit more, the approach that we are using in Blue-Cloud. And I will use, let me talk about, 3 different steps. Because in the first step, we act as a mediator, right? Because we collect, services available, in the EOSC community, let me say, so that are provided and are exploitable by the research community. But, when we integrate these services and make them available to our community, we tailor them. It's not only a matter of technology. We use a technology that is delivered by someone else, but we tailor to the needs of the community. So this is our work as mediator. For example, in all the virtual laboratories, they exploit, the notebooks. We know that the notebooks are, very common way, to perform now analytics. But all the different, our virtual laboratories, all of them have a different configuration of the notebooks. The same technology tailored to the needs of a specific virtual laboratory. So we pre-install all the libraries that they need. We pre-configure, the notebook environment, with let me say, the system characteristics that they need in terms of, for example, of RAM or CPUs and so on. So at the end, each virtual laboratory has the same technology tailored, for the specific needs. So in this first step, we act as a mediator. Then instead, when we start supporting the scientific part, we act as a sort of incubator, because we let people, communities, to incubate their new ideas, and to make them, to develop them in this environment, and to develop them to make them, at the end, services for the general audience. So in this phase, we deliver resources to our groups through the virtual laboratories, and as an incubator. And then when they are ready, we change our role, let me say, and we become service provider. Because by using, let me say, our core technology, we can deliver services with business continuity, offer, techniques for disaster recovery, and ensure, high availability and accessibility of the service. And this is out of the, let me say, the researchers have not to invest their effort to do this, because this is covered by Blue-Cloud. So at the end, the people develop their science, they make their products, and when they are ready, we operate this service for them, and we make them available to the general public. I mean, to the other scientific community at large. So, and I believe, this role, these 3 steps, part of our role is, make possible to contribute, to EOSC as a thematic, pillar, let me say.
Yeah, so I would say the key word is co-creation, what I hear from you. Co-creation between technicians and experts in technology, and also, of course, excellent scientists that know their trade, they know their data, they know what they want, but they need support, let's say, being able to use all the facilities that are there. And that's something, in this case, let's say, you can really say that's a role model for EOSC, because if they would apply that in more thematics, I think there will be, it could be a snowball effect. And we really need this co-creation. It cannot only be, let's say, from one side, from the scientist or only from the technician, but it must be together. Okay, yeah, good. I want to see how we're doing for time, maybe, not least. We still have, we can do another round. Okay, good. Then I continue. Huh? You're also scared. No, I'm not scared. Sorry, we're doing timekeeping. That's something else. It's not. Yeah, let me see. I go to Jean-Olivier again, let's say, and I would like to say that, ask you, that you have set up now a technical pipeline, let's say, for this genomic demonstrator. Do you think it can also be used for other types of data, and also for, and how could then the Blue-Cloud be supportive of this? How can we, in fact, support other researchers from outside to reuse your pipeline for other purposes?
So the answer to the first question is yes.
Okay.
That's going to be brief.
But how?
And the difficult part is how. So what we learned and what we implemented now is that it's nice to produce a map, but if you don't if you don't compute the uncertainty associated to it, it can be misinterpreted. Mm-hmm. Okay, and so this is where the Blue-Cloud can help. Is that the basic approach that I presented. It has existed for a while. Still, I mean, the algorithm that we implemented, it was actually released, published 6 months after Blue-Cloud started. So we're at the edge. But then the fact that we strove to compute the uncertainty together with it, we strove to make it available, I mean, to make it applicable to different, to a wide variety of input. That is where the Blue-Cloud helps, because uncertainty means bootstrapping in our case, which means a lot of computation. The fact that the technical stack to go from the data to the maps is not trivial. It requires setup, it requires expertise, it requires computing time, and that is what the Blue-Cloud offers.
Mm-hmm. And that means in practice also that you can, let's say, if there's interest from external researchers, we have the space, computing and storage, but we also have the expertise and the help, let's say, available from our experienced developers. And that's your message, more or less.
Yes, and I mean, already for what we have done, everything is available, so I didn't insist on the fact, but yes, it's in a VLab, etc. And again, we use 0.02% of the data, so there's room, even with just that data. And then what we plan to do is to extend it to other kinds of, let's say, more classical biological data.
Mm-hmm. Mm-hmm. No, it's good. Then maybe Patricia, you, of course, you're a VLab. What is your future perspective? If you look now at Blue-Cloud 226, let's say, where do you want to go? Let's say, what's the next step in the development, or your ultimate goal, maybe even? But that's beyond the reach, of course.
Yes. Well, before jumping into Blue-Cloud 2026, we are now putting a lot of efforts on exploiting our results. So we have I think we have solved very well Blue-Cloud and how to find our products in Blue-Cloud, but we still want to have more accessibility to our products beyond Blue-Cloud, such as integrating them in the EOSC catalog. But as well, we're working now for one of our products to be published in the EMONNet central portal that has been just recently released. So I think we can then reach a bigger community there. As well, the Phytoplankton product has been already ingested in the SEMEMS data catalog. And in the future, for Blue-Cloud 2026, we are expanding the third product, the MPZ model, which has been applied for now for the Belgian part of the North Sea, but the plan is to have it in other regions. We have partnered with colleagues from OGS in Italy, and we will apply also carbon data. Sorry. So by using a different and additional data type for this model, we can as well harmonize two different data infrastructures like LiveWatch, where we are using our phyto and zooplankton abundances together with the carbon data from ICOS, which is as well a blue data infrastructure. So yeah, that's the plan.
So it means also that, let's say, it's very well integrated with existing other infrastructures that are also you, let's say, partner in, or that are related to the work that we're doing. And that's again is of course one of the I would say one of the key factors in the whole Blue-Cloud approach. Let's say that we have to do it with the others, together with other infrastructures, and not trying to do it all ourselves, but make use of the best people, the best services, the best data, let's say, and based on this, bring it together and make it then available for the wider community. And that's and then not only a closed circle, but an open community, because that's also part of the remits of the Blue-Cloud. And I think that's also one of the things that drives all these people in the Blue-Cloud, that what they're doing is not just for themselves or, let's say, a closed circle, but it has much wider implications and opportunities. And of course, that's also the only way that we can really help to restore the oceans or contribute to restoring the oceans, because you need a larger community than only a few projects that can do that. Okay, after these philosophical words, let's say I would like to... I can't help it sometimes, sorry. But I want to go again to Lino. Let's say maybe a last question for you. You talked about using services from EOSC and also, let's say, how we develop them further by the three-step process. Can you also say what we give back to EOSC, other than being a role model, but also in a concrete way, how are we integrating services into EOSC, for instance?
Okay, so let me say that clearly we, let me say, we registered, the 13 different services developed by our virtual laboratories, our demonstrators in the EOSC marketplace. And when you register in the EOSC marketplace these services, you get also, additional, services from EOSC. For example, now these services that we operate for Blue-Cloud are also monitored by EOSC. And if something is not happens, so they become not accessible for any reason, we receive an immediate, alert from EOSC, for example. And this happened in the reality, not because the services were not accessible, but because there was an issue, let me say, one of the DNS server, on the network. So the services were accessible in Italy, but not outside Italy. And this is hard to discover, for example, for different science that is located in Italy only. So, I mean, this service from EOSC, was really appreciated and enabled us, to solve the issue, quite rapidly. So, clearly, we register also the capability to, in EOSC, to as common core services, the ones that are not, not developed by the demonstrators, but are our enabling common technology in the EOSC marketplace. And the idea is to promote, this approach in such a way that what we did in Blue-Cloud with our consortium can be replicated with other communities, through the EOSC. At large.
Okay, thank you. I think we have now about 10, 12 minutes left, let's say, on the program. So I would like to ask, are there any questions from the audience? And if so, please hold up your hand and use the microphone then. I see already in the back there a hand up. So please go forward. And also, to who do you want to address your question?
So let's see if that works. So my name is Tim Kleinschek from Ruđer Bošković Institute, Croatia. Thank you for welcoming us here. And I love, so actually, I think it's the question is most relevant for Patricia's, sorry, I don't know, presentation. So the stuff you've shown with the phytoplankton, zooplankton, and other variables that you're tracking and modeling, I think it would make a lot of sense to try to make use of local data all over the world as being collected on these variables to validate and train, so to validate the satellite stuff and train neural networks that are guiding your models. And I was wondering if you had any plans of trying to do this. It's not a citizen science, but like crowdsourcing of validation data effort or something like that. Thanks.
We have, because we only had 5 minutes to show the results, I did not explain the validations, but there has been the models validated with in-situ data, and they were scoring very good, the score, the R. So yeah, we have done it. Now, regarding to the second question, I think it's a good idea. But when you mean local data, like we have done it with, like for instance, the phytoplankton product was done with the local database at LOV, but I think the question here is this: how we can access this local data from. That you refer, like from...
No, absolutely. It's something that should be a concerted effort. It's not something a particular person can do, and it seems to me like it is a good fit for the Blue-Cloud initiative, or at least to go towards the European Commission with suggestions like that. Because I was a part of the work program committee for the Horizon 20. For Horizon Europe, Work Package 6, right? And we were discussing, these opportunities that we can use local data, and maybe you guys can also push from your side toward in that direction. That was the idea.
Okay, that's a...
Or include something like that in.
It's a good suggestion.
Can you say something?
But yeah, it's just so I have two hats in Blue-Cloud, and one is part of a data collection initiative. I think what was shown by everyone is that Blue-Cloud starts with the data aggregation service, and that for this to work and be sustainable, then the data should flow in these things. So for the part that I was responsible for is to aggregate plankton imaging data, and so we've done it, and we've done the work to connect, and then it's about outreaching, I would say, to the scientists to say, okay, well, we have this easy-to-use tool to get your data in, and once it's in, then it can be merged with all the rest. And actually, there's EMONNet as EMONNet data grants that are meant for this, which we benefited from. And so for me, that's the absolute key. That especially biologists were not very, very good at sharing data. This is changing, and we have tools to make it change for the better, to integrate in those pipelines.
Thank you.
Other question? I see Sara in the back. Sara Caravelli. Yeah.
Does it work? Yeah. Hi. Sara Caravelli from CSC and the EOSC Association Board. I have a more curiosity question about the institutional uptake of the solutions that you have been using in Blue-Cloud. Because, I mean, this is one of the main issues that, in general, there is with adoption, right? That a small group of researchers or a team is working with a great tool, but then it's very difficult to convince the organization to keep using this tool. So how did it work in your experience at your institution, and if you have any recommendation? I mean, I know, for example, that FAO has a very good best practice here because they've been using the VRE for years and they have adopted it as part of their strategy, but I'm wondering more about the others. Thank you.
Maybe I can give a first start. If you look at the follow-up project, let's say we want to work also on what we call best practices, so become part of the Ocean Best Practices initiative, which is run also by the IOC. And that means that, let's say, we're going to document all the experiences and also make it easier for others, let's say, to have the uptake of the methods, of the services, and of course also the, let's say, the user experience. And that's something that by working together with the OBPS, let's say we have a global reach, and also we have a common approach to this. Let's say we reach out to much more users than we would normally do if we only keep it for the, let's say, for the Blue-Cloud as a project. And that's one way to bring this experience, because that's also, like I say, it's really in the remit of the Blue-Cloud is to have this experience wider than only those in the project, because it's we want to reach out and learn, and also we need feedback. That's the other side. We also need to collect a lot of feedback by which you can improve the services, but also the way how you are, let's say, now documenting and bringing them forward, because that's not always easy. And also maybe you've seen also in the presentations, let's say over time we also learn, because in the beginning it was not really smooth, but over time the presentations and I hope it's more smooth for all of you, let's say, to understand what we have been doing. Of course, not a nitty-gritty, because that's also for me very difficult sometimes. But it's, but that's the way, let's say, that we really bring it forward and share with the larger audience. Is that a little bit what you're thinking of, or is that you have more in that sense?
Yeah. I mean, that's a very good example, and I think that's I don't know. I have the impression that now with the community it's a the same problems.
They're turning you down now, too long.
Yeah, but I was wondering more like an institution like VLIZ, for example. Yeah. So how are you approaching in general? I mean, not just in relation to Blue-Cloud. Yeah. That was.
Yeah, that's another thing, of course. Let's say when you want to change the world, start with yourself. They say so. Stay close in your own institute, and also do local presentations at your institute, maybe coffee breaks or whatever. And that's always a way, let's say, to bring things further, because it's always interesting to see you're talking to somebody from a not so big institute, and you say, "Do you know about the project?" And they have no clue what it's about. Well, their institutes largely involved. And that's also something that, of course, we have to do more, and that means we should really work on this. But okay, but I want to go to Guango over there, let's say from EMSO. He also has a question. Guango.
Can you hear me?
Yeah.
Well, I have a very general question for Jean-Olivier. I was a little bit impressed about the map you show about even 0.02% of the data about genomics and platform. And the question is it seemed that after some moment it disappeared, so I need to be fast. Well, the data you provide is coming mostly from Tara Oceans or not? And the question is, we are looking into the whole world column, and we are planning to deploy across the moorings a set of optical sensors for genomics. And the idea is to understand what are the influence of this climate change, etc., and on the area. Then you put something beautiful, I like very much, about this sort of generic map of the genomic or the ocean. If it's the whole ocean, an average, or is it special places, or and what are the things change the genomic with depth or not?
So does that work?
Yep.
Yes. So far, again, we can't go into details, but yes, that was only the surface, because you have to start somewhere. Blue-Cloud 2026, the goal is to go 3D also, and local, especially around the coast of the EU. You can't, if there's places where you have richer data, then this is, we should exploit that richer data. At this point, we have done a sort of lowest common denominator approach, only averages only the surface, but the goal is to go further in that direction also. Theoretically, everything's possible, and then it will depend on the data, and again, it will come back to assessing the quality of the model. Basically, it's not enough to give a map. You have to give an index of the confidence that people can have in that map.
We have 1 minute left, so I'd like to give the word to Nicolas for his question. No, I see in the chair. He's in the chair. Yeah. You have the honor to have the last question, Nicolas. Yeah.
I need to get used to these physical meetings again. Sorry. No, I had a question very similar to Sara about the sustainability. And of course, the digital twin ocean is one of the exploitation paths, because the digital twin ocean is being conceived today very differently than the typical call for research proposal, in the sense that we are trying to construct something which will be maintained over the years. So we are building the research and the development for it, but the idea is to have, in a few years from now, an operational service, a public service, supported by EU programs, but maybe by other programs, maybe by a hybrid business and public model. So my question for you would be, have you started analyzing what are the key deliverables or outputs of Blue-Cloud 26 that might be transferred to the digital twin ocean? And of course, you have 2 key partners in your consortium for that, is the 2 entities which we asked to develop the core infrastructure. And this applies, of course, for generic tools, but also for some of the demonstrators.
Yeah, there's a very long answer to this question, but we can also go for the short one. As I said before, let's say DTO, Digital Twin of the Ocean, it's a little bit about how do you see that perspective? Is it the sum of the total, or is it only the roof? And of course, if you have a roof is, you need the total to be able to carry the roof. And the total are, let's say, the research infrastructures that really are connected to all the people that collect data, and also connect to the platforms that collect data, and to the scientists that process data and create very good quality, high quality data, because only data just for essay is not useful. And this way we have the research infrastructures, then we have EMUTNet, we have Copernicus, which are already prominent initiatives involving a lot of scientists, but also involving, let's say, another way of looking and producing generic products, let's say, a growing portfolio of products, which are again only possible because there's a continuous data flow. And then, of course, you have the next step, which is DTO, and DTO says we're going to add also this element of dynamic modeling and having this what-if questions and on-the-spot assessments, I would say, which again demands, it's a very high ambition, of course, but it demands enormous amount of availability of data, but also, let's say, high-quality data. And that means, of course, that if we DTO, if we really are serious about this, and we are, I think, then we really should make sure that we do not forget, let's say, all the underpinning pillars. And Blue-Cloud is in that community also, I say, a player. It's to bring those pillars together and more integration, more streamlining, more fairness, etc. But then you need really all those elements, let's say, to be equally sustainable and also being expandable, because it's because we still are, there's still a lot of data out there that we are not reaching. And also there, let's say, with imminent ingestion, for instance, we do our best to reach out to others. And there's also other initiatives, also from the Commission itself, let's say by Ocean Partnership, by other ways, let's say, to get hold of more data and to mobilize more data providers in the same rhythm and the same trunk lines, I would say. But it means that we have to look at the total. So I think if we only say we're going to invest in the DTO as such, the top layer, then you will not have a winner. But if you say no, this is the, I know. But I want to hear you say, okay, loudly, because that's the only way. Because let's say it's like a big pyramid. The pyramid starts with data collection at the bottom, and there we already have to reach out further and make it more streamlined. and then we can make fantastic knowledge products and data products, and those products really can then answer and make the difference. Let's say make the difference, and that's so that again is a little bit preaching here, but I'm sorry. Okay, with this I'd like to close this session, and I think we have now a photo moment. We have a yeah.
We're going to break for lunch. Please be back at 1:30. Lunch will be served outside. And indeed, if we could please ask our guest speakers today to stay with us, we'll do a group photo outside at the fountain, I think it is. While you're having lunch, please pay attention to the screen as well, as we will be giving you the QR codes to some fact sheets that also sum up part of the key findings of the results of the demonstrators that you've heard about this morning. So we'll see you back at 1:30. Thank you. So, welcome back. Welcome back. I hope you all enjoyed your lunch and are ready to move on with our agenda for today. So, this morning we've given you a taste of some of the key achievements of the Blue-Cloud project. You've heard from our Blue-Cloud colleagues about the services that the project has piloted, some of the specific assets that have emerged as examples showcasing what a digital ecosystem like the one piloted by Blue-Cloud can deliver. And as I mentioned this morning, we'd like to use this second half of the day to look at the road ahead. From the outset of the pilot project, I guess we knew that this 3-year effort could be an experimental stepping stone towards something bigger. That's what a pilot generally is. And so also from the outset of the project and as part of our work plan, we've been working in the definition of a long-term vision for the future evolution of these efforts. So as to not to just, I would say, showcase potential, as we've done this morning, but also to reflect on how the legacy of Blue-Cloud could be further used, evolved, and upscaled in the future, also considering other wider developments in our landscape. And that's what we've done through the Blue-Cloud strategic roadmap to 2030. And what I would like to do over the next 25 minutes is share with you a very high-level summary of the key contents of this strategic roadmap, which we feel might be useful to frame and to inform the discussions that will follow in the next panels that make up our agenda for today. And more specifically, may I please have my presentation up there? Yep. All right. So more specifically, I would like to, first of all, building on what has been shared this morning, shortly reflect on how we see Blue-Cloud adding value to the marine knowledge value chain. And to that end, I will walk you through the process that has helped us to shape a long-term vision and a mission guiding the future evolution of Blue-Cloud, feeding from extensive stakeholder consultations. I will then give you a quick overview of the key paths of action that we have envisioned as key components of the roadmaps towards the delivery of such mission. And I will close with a short summary of a set of policy actions that we recommend moving forward and that we feel are critical to pave the way for the successful implementation of the roadmap, but also really to maximize Blue-Cloud's impact and contribution to the wider marine knowledge landscape. So from the beginning of the Blue-Cloud project, and as it has been mentioned this morning, the overarching ambition of Blue-Cloud has been to harness open science to contribute to the successful evolution of the knowledge system that is required to inform progress towards the goals of the EU Green Deal, the G7 Futures of the Seas and Oceans Initiative, and the UN Agenda 2030. And that's, I would say, probably why the Blue-Cloud project was funded in the first place. However, the task that we've had before us during the project has been to better understand and explain what is the specific added value that Blue-Cloud can contribute towards such a knowledge system. And in a way, explaining Blue-Cloud's added value to the marine knowledge landscape, it's probably a bit easier now that we can see the results of the work undertaken, as you've been able to do this morning. As I would say that Blue-Cloud's added value is really implicit in these results. So this morning you've heard about new algorithms that have been developed and that eliminate the hassle of harmonizing access to heterogeneous data sets from different marine data infrastructures. We know that harmonizing data is by far one of the biggest headaches that marine researchers face when conducting research, especially if that research requires queuing or querying huge data sets. And it's, I guess, also a headache that sometimes a good fit-for-purpose algorithm can contribute to solve. And Blue-Cloud shows how providing marine researchers with such algorithms, making them available in a platform that also offers computing resources, can help them to be more productive and, most importantly, also shorten the time that is invested in transforming research outputs into actionable information. We've also seen how Blue-Cloud's resources have been used by researchers to advance more efficient modeling of ocean variables, This morning you've heard about new models that have been produced to better understand essential ocean variables such as zoo and phytoplankton. And as a result, as you've heard, one of the Blue-Cloud VLabs now offers new maps of plankton abundance. And I guess this is an important result on its own, but maybe more important is the fact that Blue-Cloud's approach to open science means that the underpinning recipes that have been used to generate these maps are also openly available to other users. And during the Blue-Cloud Hackathon, as it has also been mentioned, we saw how external teams of researchers, some of whom are, by the way, here with us today, made use of these maps and these methods to develop a new tool that can help to monitor and predict megafauna movements, which in turn can, for example, contribute to reduce risks for protected species, such as risks for ship strikes with whales, for example. Now, the colleagues who set up this VLab probably didn't have this application in mind, but I guess that's, in a way, the beauty of innovation, that you're never sure how it's going to manifest itself. But the truth is that by making these maps openly available to wider communities, and by providing hackathon participants with tools and with resources to further experiment with them, new solutions emerged from the community to problems that were not necessarily being targeted in ways that had not been previously foreseen. And that's, we think, a very important result. Another noteworthy result is the environmental data analytical services that have been piloted, which offer promising potential across different thematics, but probably most especially around biodiversity, which, as you very well know, is central to the delivery of the EU Green Deal. And I guess I remember that years and years ago, when I studied economics, we were introduced to the concept of the balance scorecard. And I'm sure that you've all heard about this, but basically this scorecard is like the dials in an airplane cockpit. So it gives business managers real-time information to measure performance against business objectives. And likewise, today, we know that although monitoring marine habitats, species, ecological processes is very, very challenging, it is also key to informing policy choices. Blue-Cloud has showcased how artificial intelligence can be harnessed to generate a range of marine environmental indicators as early warning solutions that could, for example, help to monitor or anticipate the effects of climate change, just like it has also showcased how artificial intelligence can be harnessed to, for example, classify coastal areas for aquaculture purposes using satellite images, as Anton has explained this morning. And I guess these are just examples, but in the future, Blue-Cloud could evolve to support a suite of environmental services, forming a sort of a single digital dashboard that could also allow monitoring different predefined biodiversity indicators to measure progress towards policy objectives. And we're obviously not there yet, but I think we can say that we've definitely showcased potential in that direction. And finally, we've also confirmed the role that Blue-Cloud can play in strengthening collaboration at a global scale. So the fact that Blue-Cloud allows teams of researchers to work remotely together, sharing a common workspace, analytical tools, easy access to a wealth of marine data, that's what is allowing FAO, for example, to use Blue-Cloud to evolve its global record of stocks and fisheries, as you've also heard this morning from Anton. And I guess they're using Blue-Cloud not only to validate records more efficiently, but also to enrich them with other data resources like environmental data coming from EMODNet and other services, or to provide training on implementation of SDG 14. So I guess we could say that Blue-Cloud has also shown value as a cross-institution, cross-domain platform for international collaboration across the global ocean. Now again, all of these results showcase great potential, but what does this mean? Where does Blue-Cloud fit in the overall marine knowledge landscape? Who is it going to benefit? And what do these actors need from Blue-Cloud? What are their expectations? To respond to these questions, we've engaged in an open dialogue that started in 2020, involving not only Blue-Cloud partners and our external expert board, whom we've consulted through a number of workshops, but also the wider marine community through different surveys that we launched in 2020 and in 2021. We've also had one-to-one conversations with a good number of key targeted organizations, and we have also invited input of target user communities through a hackathon that we held earlier this year, also as I mentioned before. And I would like to first provide you with a bit of insight into some of the messages that have emerged from these stakeholder consultations. And obviously in 20 minutes I cannot share a full overview, but I would like to at least share some key messages that can help you to better understand why is it that we have shaped Blue-Cloud's future ambitions into their current form. Through this stakeholder consultation process, we've been able to engage with whom we consider to be the primary users of Blue-Cloud. And by primary users, we mean those users that really interact with the Blue-Cloud platform. So the users that actually log in and access the resources that we provide them to support their research. And we know that these researchers are mainly marine researchers, data scientists, software developers, and computer scientists. And what these users have told us is that what Blue-Cloud offers them is really well aligned with their needs. So basically, they do appreciate having easier access to data from different repositories without the hassle of having to jump from one service to the next. The fact that they can push this data into a VRE on the cloud, and the fact that within the VRE, they can use better versions of the software tools that they normally use to process data is not only convenient, but it also empowers them to a more productive use of their time, increasing their scientific productivity. And when we ask these users, what else could we give you? The response is actually more of the same, but in larger quantities. So basically more data, more computing power, to the extent possible also more of a cloud, more of a real cloud experience. But they also tell us that they would like to turn to Blue-Cloud for training opportunities to help them make the most of all of these resources, and also for support in the application of artificial intelligence to their research. They also suggest adding new features, like having access to ocean models or to preloaded scenarios that they could use as a base to run their experiments, or visualization tools that they could use to make it easier for them to share or to showcase their results. And they've also hinted other ways in which Blue-Cloud could probably improve. So, for example, they've told us that they do not really appreciate having to sign up twice to use some of our services, or that they are not too keen sometimes on having to go through a shopping basket to access data. And, well, I guess this is all important information that we need to consider. So both what we're doing right and what we need to improve. Because if we want Blue-Cloud to be able to continue growing its user base, these primary users have to really be at the forefront of our thoughts. And if we fail to do so, our users might just simply go somewhere else to get what they need more conveniently. So I guess what I'm trying to say is that we may think that Blue-Cloud is perfect, and we might convince our funders that Blue-Cloud is perfect. But at the end of the day, if our primary users do not share our perspective, then we run the risk of ending with a perfect €6 million platform that no one uses. And that's, I guess, why we are also very, very proud of the interactive conversation that the Blue-Cloud project has kept with its early pilot users. And that is why also the Blue-Cloud Consortium has really gone the extra mile to respond to user requests already throughout the project. And my colleagues from CNR here can tell you all about these efforts. We've all really gone the extra mile to respond to what users were immediately requesting. And this is also why keeping that conversation alive is really a very important, a central part of our plans ahead. Now, through our stakeholder consultations, we've also invited feedback from secondary users of Blue-Cloud. So to us, these are the people, the organizations that can directly benefit from what happens in Blue-Cloud, or that can have an influence in how Blue-Cloud develops, although they do not necessarily interact with Blue-Cloud on a daily basis like our primary users do. And here, for example, we would have government agencies that can build services based on what is produced in Blue-Cloud to support monitoring of policy objectives, or marine data and research infrastructures, or blue economy enterprises that can use what is produced in Blue-Cloud to support their activities or to service their users. And what we hear from this second layer of users is that, well, first of all, marine data services and research infrastructures see value in the role that Blue-Cloud can play in terms of making their data available to wider audiences via the European Open Science Cloud, via EOSC. We also hear that there is potential in Blue-Cloud helping to accelerate the development of the future EU Digital Twin Ocean. We've discussed it this morning, but I guess that the EU DTO will have to harness the collective effort of research communities across Europe to build a fit-for-purpose replica of the ocean. And what we hear is that there seems to be potential in coupling a more top-down approach to the backbone infrastructure that will be needed to support the DTO with a bottom-up, community-driven approach to the myriad of digital components that will be needed to build the fabric of this replica. Also along these lines, our stakeholders are telling us that when you look at the marine knowledge value chain, there seems to be currently a need to close a certain gap between ocean observing communities and ocean modeling communities, and that Blue-Cloud has an opportunity to become a link that contributes to better connect these communities. They suggest, for example, establishing collaborations with modeling organizations to build their models into Blue-Cloud, to service users, those users that may wish to experiment with piloted scenarios, which can maybe also contribute to inform new ocean observing gaps or data needs. We've also heard from trade associations that they see opportunities for Blue-Cloud to become a natural partner in the development of digital twins, and that Blue-Cloud should be offered to academic communities to train the next generation of marine scientists. And we've also had the opportunity to exchange with our funding institutions, whom we consider to be tertiary users of Blue-Cloud as part of our wider stakeholder base, that basically have told us that whatever Blue-Cloud does or becomes has to be useful for policy purposes, which is something that we knew, but I guess hinting that if we really wish to achieve further support, we need to very well explain what's the unique contribution that Blue-Cloud is bringing to the table. And I would say that the interesting thing is that as plans for important EU initiatives start to unravel, we also see more clearly how Blue-Cloud can become one of the many building bricks supporting such initiatives. So, for example, we hear from the European Commission that the Green Deal data space will need to be supported by sound technical infrastructures, including facilities for AI testing and experimentation. And that is a bit music to our ears, because that's exactly what Blue-Cloud can be set up to be. So, looking at what has been achieved so far, and looking ahead at some of the opportunities that have been identified through the stakeholder consultation process, we see Blue-Cloud positioning itself as a community of practice and as an incubator that brings together marine researchers, data scientists and modelers, computer scientists, software developers, and gears them up with a digital ecosystem that provides very specific resources that they can harness to produce the algorithms, the methods, the services that improve and support advanced marine and freshwater data analytics. In a way, bringing innovation into the way that the Blue Realm is researched to, in turn, enable faster generation of actionable knowledge. So, in other words, what Blue-Cloud can specifically bring to the table is a community of practice that is empowered by a digital ecosystem whose members can turn to in order to test and develop better ways of and methods of analyzing data, including through AI testing and experimentation, and that provides them with support, with training, with opportunities for interaction with other peers to advance marine data science and analytics. And in turn, this enabled community and the infrastructure and the services that support it can bring huge benefits to the marine knowledge landscape, as it can be harnessed to become, first of all, a very dynamic incubator of the very components that are needed to build and fuel the analytical data services or the digital twins that can produce the knowledge that is needed to inform policy or blue economy objectives. And I guess we do see Blue-Cloud playing a key role in harnessing the collective intelligence of the marine research community to accelerate the production of the underpinning components of these knowledge instruments. Maybe one or a few institutions working together can deliver all of these components on their own, but we do empower research communities with the resources that they need. We just might get there a lot faster. We also see Blue-Cloud playing a key role in helping to federate and bring existing marine data into the European Open Science Cloud, together with the methods, the services that are incubated in Blue-Cloud to make them available to wider interdisciplinary research communities. And we see potential in harnessing the work and the digital assets that emerge from this community to potentially enhance the marine data space that is needed to fill and nurture the future EU Green Deal data space. So we know where we are, and we know where we want to get. And so in the Blue-Cloud roadmap, we've envisioned 5 strategic paths of action that will guide our way forward. The first one has to do with ensuring a sustainable flow of data into Blue-Cloud so that we can continue to service our primary users' call for more data. And with that in mind, Blue-Cloud's data discovery and access service needs to continue expanding with data coming both from existing services and infrastructures that are already feeding data into Blue-Cloud, but also with data from other infrastructures. And in the near future, we are thrilled that we will be establishing links with EMSO, with EMOBON, and CEOS, all of which are infrastructures that will join the Blue-Cloud 2026 work plan. Our second strategic path of action seeks to continue to inspire the community with examples of fit-for-purpose demonstrators that showcase how the application of artificial intelligence, machine learning, or big data analytics can contribute to accelerate progress in the underpinning data processes that contribute to support the generation of actionable information. And our plan is to continue focusing on essential ocean variables, but taking further steps to showcase how these data flows can be sustained by means of workbenches. And we also plan to continue enhancing some of the existing VLabs and to further explore how they could be further set up to service public and private sector users. Our third strategic path of action is geared at ensuring the robustness of Blue-Cloud's underpinning infrastructure. Maybe more importantly, its compatibility and future interoperability with other key infrastructures, very especially those connected to the future EU DTO. And we are planning to transform what is now still an informal conversation with the project that will deliver the backbone infrastructure for the DTO into a more formal task force, also engaging with other initiatives that are building different components of the future digital twin ocean. And we will, of course, continue to work to ensure long-term alignment and integration with EOSC, both of which explains why today's agenda has been structured as it is. Our fourth strategic path of action is geared at continuing to grow the Blue-Cloud community. First of all, by attracting more users to Blue-Cloud through excellent service and user value, but also engaging with other research projects and initiatives in the marine domain, as we have already been doing through our Synergy program, which has already successfully brought new communities of users on board Blue-Cloud, and our colleagues from JERICA-RI are here today as a good example of that collaboration. And we plan to set up a training academy to continue building skills amongst researchers on the application of fair data practices and making the most of Blue-Cloud resources, which we also hope will contribute to not only retain, but also to attract new users to Blue-Cloud. And finally, our fifth strategic path of action will seek to continue ensuring that we make connections with other EU and international communities. In the closer future, starting a conversation with lighthouses and blue parks initiatives connected to the Horizon Europe program, but also with the Green Deal data space community of practice that will start to shape in the near future. And from an international perspective, connecting with the Ocean Best Practice Repository of Methods of the International Ocean Commission of UNESCO to make sure that Blue-Cloud contributes to support international efforts. And this is, as Dick has mentioned this morning, something that will be tackled already with the start of Blue-Cloud 2026. But we will, of course, continue to further intensify this collaboration into the decade. Now, we feel that this will put us well on track to make progress towards delivering Blue-Cloud mission, but of course the Extent to which we are successful will also depend largely on the wider context surrounding Blue-Cloud, which is why we have brought a number of policy recommendations into the roadmap. And altogether, we have put forward 12 policy recommendations, which I'm sure you cannot read at all, but I'm going to highlight 5, which are probably the most relevant for our conversation today. The first one has to do with ensuring that open and free data continues to flow sustainably not only into Blue-Cloud, but throughout the whole marine knowledge value chain. And I think Dick made a comment to this end this morning. So basically, through our stakeholder consultation, we identified concerns from the community that resources invested in initiatives such as Blue-Cloud could potentially divert resources away from ocean observing efforts or from existing data management efforts. So we really want to make it clear that the only way in which Blue-Cloud can continue to contribute value is by ensuring that all the underpinning elements upon which Blue-Cloud is built continue to function sustainably. And that includes Europe's ocean observing efforts, but also the long-term EU services, the initiatives, the research infrastructures that feed data into Blue-Cloud. They need to be well-funded so that they too can evolve to deliver on the needs of cloud-based data sharing and open science. The second recommendation is maybe more of an open invitation to EU and international policy bodies to use Blue-Cloud to build the analytical services that are needed to inform policies or to monitor progress towards policy objectives. Through the demonstrators, we've showcased what can be done with a platform like Blue-Cloud, and we will continue evolving these services. But we hope that you're now convinced that you can turn to Blue-Cloud not to just showcase potential, but to actually build and deliver the services that you need. Another key policy recommendation is to invest in the next generation of marine scientists by including the use of artificial intelligence, machine learning, and FAIR practices in university curricula, but also, again, inviting the use of Blue-Cloud to support training efforts in that direction. We also invite policymakers to explore ways by which research teams that evolve open science methods or services that are proven useful to long-term EU initiatives could be somehow rewarded, which in a way is maybe connected to a higher conversation on future plans for the terms of reference that will guide the exploitation of digital commons across the EU Green Deal data space. So basically, how can we reward excellence in the open science that contributes to build our digital commons? And that's maybe a conversation that can be picked up during the next panels that are envisioned for today. And finally, the last recommendation has to do with helping to ensure that the results of Blue-Cloud are not lost, but also taken up by other ongoing efforts. One example being the EU DTO, but also other EU and global environmental initiatives, such as the UN Biodiversity Convention or the Framework Convention on Climate Change. And that's all from my side. So I really hope that this intense storm of information is useful to provide some food for thought for the next panels. If you would like to revisit these ideas, you can either read the short executive summary of the roadmap that we have provided you, or its full version, which will soon be available in our project's website. Before wrapping up, I would like to thank all the Blue-Cloud partners, really everyone on board of the Blue-Cloud Orchestra, including our ESEP members, and everyone who has taken time to contribute to shaping Blue-Cloud's roadmap. We are only thrilled that we will have the chance of already seeing some of the first steps of this roadmap through, thanks to the new Blue-Cloud 2026 project that will kick off in the new year. And I guess that today is a great opportunity to get the conversation going on these next steps. So with this in mind, I would like to invite my colleague Sara Pittonet to join us on the stage. And our panelists, should they join now, Sara? You will call up for them?
I'll call it, but
all
first
right.
I think Julia deserves an applause because the work the work she led on the roadmap is really huge. She's done a really good job in guiding all of us through this giant effort, and coming up with 5 actions was not easy in this context. So take a look at the executive summary, if you can, a minute. Okay, so Now, so the EOSC started back in 2016, and we now have learned that Blue-Cloud is the thematic EOSC for the marine domain. So now I'm happy to welcome on stage some of the key representatives of the European Open Science Cloud funders, governance bodies, initiatives, and actors to reflect on the lessons learned from Blue-Cloud and how interlinkages with the EOSC can be built. So I'm calling Mr. Michel Schuppe, Senior Expert of the European Commission and Team Leader of the European Open Science Cloud in the Open Science Unit of the Directorate General for Research and Innovation, DG RTD. He's a geologist by training. He got a doctoral degree in sciences from the universities of Leuven in Belgium. The next one is Andreas Petzold, an atmospheric scientist with long-lasting experience in the measurement of climate-relevant gaseous species and aerosol properties across the troposphere in various environments. He is leading today the research group of global observation at the Institute of Energy and Climate Research Troposphere of the Forschungszentrum Jülich in Germany. He's also a professor of atmospheric physics at the University of Wuppertal and serves as member of Scientific Advisory Group Aerosols of the Global Atmosphere Watch Program of WMO. And he's also with us in with his role of coordinator of the European Research Infrastructure, IAGOS, and the leader of the VLIZ EOSC-related project. The next one is Sara Caravelli, that works as an EOSC program manager at CSE, the IT Center for Science in Finland. And she is the coordinator of the EOSC Finnish Forum, the EOSC national structure supported by the Finnish Ministry of Education and Culture, in charge of organizing the EOSC activities at country level. Sara is also with us today as a member of the EOSC Association. She's one of the directors there. Then I call Karl Presser, founder of Premotech. He is also a computer science with a doctoral degree on investigation of data quality and food composition. He works as a senior scientist at ETHZ in Switzerland in the Global Information System Group. He worked in an SME as a product manager, was the primary creator of Foodcase, an information system to manage food composition data. And today represents the many projects he is part of, many funded projects, such as the Metro Food research infrastructures, the FNS Cloud, the thematic food network in the EOSC. And the last one is Delphine Lobel, product owner for the coastal resilience team at Fugro. They are currently developing a digital twin with machine learning analytics to improve coastal hazards preparedness. And she was also leading the team of the See Clearly team. No, the team who developed See Clearly, the application that was awarded first prize at the Blue-Cloud hackathon in February this year. The application is a digital solution to understand the impacts of ocean plastics and on aquaculture farms in the Mediterranean. Okay, I'll join you here. Okay, can you hear me? Yes. So, Blue-Cloud is the thematic EOSC for the marine domain, and it is listed among the projects set in the EOSC Work Plan 2023. It's a great example of implementation of open science, providing resource to the three main components of EOSC, the EOSC Core, the EOSC Exchange, and the Data Federation. The first question is for Michel Schuppe. How would you position Blue-Cloud in the framework of the European Open Science Cloud?
Thank you, Sara. Good afternoon, everyone. Very pleased to be here today and very impressed by the presentation of this morning. Really, I could see a lot of developments that have happened in the Blue-Cloud community, in the marine community. And I'm happy to see also the nice connections made already with the EOSC. So I might repeat a few things said already this morning by Dick and Pasquale, or Lino. But it's good to understand also the difference of levels. I think we use the same terminology in the Blue Cloud and in the EOSC. And then when I see your plans 2026, they look very like the plans for the EOSC in general. We could use exactly the same keywords. I mean, the main difference is a question of scale. So I'm just saying this as an introduction, but I'd like to remind a few things. Before positioning the Blue Cloud in the EOSC ecosystem, I like to position the EOSC, if you don't mind, because sometimes people get lost with the EOSC. So EOSC is not a single monolithic resource provider. And as Pasquale said this morning, it follows a system of systems approach. So we are not inventing the wheel or reinventing the wheel. The point is really to provide seamless access to, but EOSC is also one of the data space of the strategy. And we, when I say we, it's the Commission, but also the member states and the EOSC Association, we see this EOSC as a transverse data space that can feed into all these sectoral data spaces. So there are many stakeholders. This is why we went for a EOSC European Partnership approach in 2021. The EOSC Association is playing an important role there to represent the voice of the research community. And we foresee several gains. Why do we join up together? Because we have a need to upscale multidisciplinary research. I will not surprise you, for instance, with the Sustainable Development Goals. This is a typical example of complex scientific issue of societal relevance, where you need to team up with different disciplines. Another gain is about scientific productivity and the acceleration of innovation. We believe that an open circulation of knowledge and data across the European research area will definitely help to reuse data that are acquired and then used only once. And we believe also that exposing those data from different disciplines can trigger new reuse scenarios of the data you know very well in your own community. So there is an innovation agenda behind this. It's also an issue of economies of scales. You mentioned several services provided to this community. Why should all individual research infrastructure fund again and again the same underlying layers? There might be a gain of economies of scales for common services across the different disciplines. I'm too long. No. I will accelerate.
No, you have your time.
Okay.
It was a wrong alarm.
So, economies of scale. And the last one I'd like to mention is public interest and autonomy by the research communities. We do not want to depend on vendor locking solutions. We believe that we have to defend the autonomy of the research process in Europe and allow for some control by the research communities. So there is an issue of public interest and autonomy. So all this to say, EOSC is a convergence process between many different stakeholders, and your community is one important stakeholder in this landscape. And we really would like to see this community very well linked to the EOSC governance, in particular to the EOSC Association. Do I have 2 more minutes?
Yeah.
Then in practice, what can you bring to the EOSC? You can bring open marine data sets that can be shared with other research communities for multidisciplinary use cases. You can implement the FAIR principles within your community. And I think EOSC is there also to provide some common understanding on how to assess fairness, how to implement fairness with your data. You can help by sharing education and training material that could be reused by other communities. You can also expose and connect some of your thematic and horizontal services into the EOSC Exchange platform. All this to say that we think you have a role to play to have a dynamic and rich EOSC marketplace in the future. And if you do it, but the other thematic communities also do it, then it will be a mutual benefit for all communities. Okay, I think I already exhausted my time, so thank you very much.
Michel. And since we have a representative of the EOSC Association with us as well, I'll ask the same question to Sara. So how would you position Blue-Cloud in the context of EOSC?
Well, Michel said it all already. So what's left for me? Actually, I mean, I will start from the last things that Michel was explaining in terms of contribution of Blue-Cloud. I think one other important aspect is the engagement. So you have the power to really engage a huge amount of communities and institutions. So that's why also my previous question before, because I mean, EOSC is a process and is also a cultural change. So we really need all of us to make it work. And I think Blue-Cloud has established a strong community and links with other very relevant initiatives. So for me, that's another contributions. And also the showcases that you have shown before, that's also our examples to make understand other researchers and other communities the value of what we are trying to implement at European scale. So I think that these are the two other contributions, in my opinion, that Blue-Cloud can bring to the table.
Thanks, Sara. And we've also learned about the importance of fairness and implementation of the FAIR principles. So one of the key outcomes of Blue-Cloud is the effort towards interoperability and harmonizations via global standards that allow the exchange of structured data across several information systems and research fields. So now I'm asking again to Michel, how do you see the evolution of interoperability and fair data management aspects in cross-disciplinary frameworks, such as the one that Blue-Cloud is introducing?
Thank you again, Sara. Yes, the objective of EOSC, the long-term vision of EOSC is to have a web of fair data for science. So not just a web of HTML pages, not just a social web, but a web where you can find and access data sets. This might take some more decades, just to quote the president of the EOSC Association. And actually, we made a study launched by the Commission on the behaviors by the researchers across the EU regarding how they deal with their own research data and how do operators of repositories do deal with data. And we have three main outcomes coming out of this. I let you judge whether this is true also in the marine community. One outcome is that only 40% of European researchers do store occasionally data sets on a repository. This means that the majority of European researchers are still using local devices, being personal devices or institutional devices for their data sets. When we think about the public investment spent in acquiring data sets for research, we might come with the question, do we want to use these data only once? And if you use it once, it doesn't mean it will lead to a publication. So there is a question there. We have to do better than this. A second observation is that 1/3 of the community only is aware of the FAIR principles. And only 1 out of 5 researchers in Europe do implement those principles. So this shows also the wide spectrum of progress we can do before having a web of FAIR data, at least in Europe. And the last observation is that identifiers are not pushed through by all communities. When a researcher publishes his data, PIDs are not always used for data or for software and codes, and licenses for reuse are not often described either. And this is a big bottleneck for the reuse of those data. So with this context, which is a rather negative assessment we see regarding fairness, the EOSC governance is tackling several issues. We have a focus with the member states to put in place policies with a requirement to implement fairness, and this has an impact on funders, research funders across Europe. We push for data management plans that are harmonized across communities, at least to some extent, and machine readable. We push for a pervasive use of PIDs, not only for data, software codes and publications, but also for researchers, for grants, for research programs, and the interlinking between all these objects in the research cycle can be done through science graphs. So we believe this would contribute to a better transparency of research in Europe. We also push for a network of trustworthy, fair enabling repositories, and I'm happy to see that in the marine domain it seems that you have already several, more than 10 repositories interlinked, so I was happy to see that. But it's not the case in all communities. And the last thing I'd like to mention, which is probably the most important, is the EOSC architecture and interoperability framework. And this should be seen as a kind of framework of frameworks. You have your own interoperability framework in your community. Not all communities are that advanced. And I think if we want to have a nice EOSC federation where data can circulate, we need to make those resources interoperable. This is true for data sets, but it's also true for the composition of services exposed in the future EOSC exchange. So this framework is important. It should be community-driven, and we have launched a call no later than yesterday on a topic regarding the governance of this framework in the future. So just the good occasion to alert you if you want your community to be joining this effort to have a community-driven interoperability framework in EOSC. Thank you very much.
Thanks. And actually, yes, you said that Blue-Cloud also contributed actively to the data gathering, the data federation part, since also of the many years of collaboration that the Blue data providers have on their shoulders. But actually, it is also true that this approach, some of them are new, very different one from the others when we come to an EOSC framework. So I'm asking the same question to Andreas Petzold, who will bring us the perspective of the ENVI-FAIR community, an interdisciplinary case as well. So how do you see interdisciplinary data management in this framework?
Thank you, Sara, and thank you first to give me the opportunity to speak to you as members of one of the most vibrant subdomains in a bigger family. So you are part of a bigger family, even you may not know it, because the ocean sciences or marine sciences are part of the environmental research infrastructures of the environmental cluster in the S3 domain. And the ENVI-FAIR project brings all of them together. So the marine research infrastructures who are here in the room, the atmosphere research infrastructures, I am part of that, solid earth RIs, and biodiversity and terrestrial ecosystems research infrastructures. You see all family members in the back. You are here on the lower left. And I was totally impressed of what you have achieved in the Blue-Cloud, because that looks like an subdomain integrated open science cloud, which you have built here. So from the, and coming to your questions, from the ENVI-FAIR approach, we had the challenge to have this highly diverse community, which requires interoperability within the environmental RIs, not even across, because we are very diverse. Working in the atmosphere, working in the oceans, working in biodiversity, there are different cultures, and we need to speak to each other or to learn the languages. And as a basis, we started, and I think you did the same here in the Blue-Cloud, we started the development of the interoperability by a twofold approach. One really comes from the bottom up, and that is a permanent struggle with making your data stewardship systems fair and keep them fair, because it doesn't stop when you have thought you've done your homework. The next thing comes around the corner. So it's a permanent work you need to carry on. It requires resources, it requires effort, it requires constant communication with other communities to ensure standardization and harmonization among the various approaches. So that was our first effort within the ENVI Fair to bring all the different communities on the same road into the same direction with a kind of a similar speed. And co-creation, Dick mentioned that already, is the buzzword here, because the efforts require two kind of not controversial, but complementary knowledges. It's the IT personnel and it's the scientists, because leaving one of them out of the game doesn't lead to anywhere. If you give the question only to IT scientists, you may get a system which works very well, but no scientist will use it. If you let the scientists only do the job, it will not work at the end, maybe. On an IT basis, I want to say here. So we need both, and I think that was one of the big lessons we took from ENVI Fair. Keep both together and move together in one direction, and this is the second part of the approach. What we learned, and I saw that you did it to a larger part in Blue-Cloud, is you use scientific questions to formulate scientific demonstrator, like in our case, it was the Essential Ocean Variables broker. It was called like that by the colleagues from EuroArgo. We use a scientific approach, a scientific question, and along that side, we developed tools at each RI which need to be implemented to allow interoperability at the end. That means the scientific question and the service you want to get out of the end. This was set as a target. And along the way, more and more of the fair enabling resources were identified, were harmonized, vocabularies were agreed, all these technical steps were done, but always driven by a scientific question. And honestly, I think this is the only way it can go. If you leave the science question out, we speak about the S in the EOSC, which is the science. So we should always be behind that. And this twofold approach, I think this is a key lesson we learned in ENVI Fair, also when we speak about interoperability among different subdomains. And we try to bring together not only the ones inside the marine science or inside the atmospheric science, but across that. And it gets more complex if you want to combine, for instance, what we try in EOSC Future, bring together atmospheric scientists and social sciences and humanities. It makes it even worse, but it's solvable. So we are on a good way here as well, always driven by this twofold approach. And I think this is the message I want to give here. Form teams, get the IT people and the scientists together, train them to speak to each other and to listen to each other. And then I think that's a good key to have success at the end. And Blue-Cloud is, I think it's a good example of that. Thank you.
Thank you, Andreas. Of course, if you have questions, feel free to interrupt, raise your hands, as well as for those listening online. So, unless you want to add anything on this EOSC topic, I know you've also read a recent interview. I mean, there's now a debate on how much the researchers know about EOSC, how much they should actually know, and a little bit what, bringing back of what Andreas was saying, build a team, and that will become part of a bigger picture. I don't know if you want to say something about that.
Yeah, maybe I can comment on this, because recently we also had our main annual event, the EOSC Symposium in Prague a couple of weeks ago, and we actually had this conversation there as well. So whether we should consider EOSC B2C or B2B. So I think that's one of the questions that we need to soon answer or give a proper answer, because this will have an influence on the future governance of EOSC. And now that's what we are starting working on the post-2027 model. This is something that the partnership, the Commission, the Association, the Member States, we are starting some scenarios, potential scenarios, and of course the delivery model to the B2B or the B2C has an influence on the cost and the governance. So I don't know, I can give you my personal opinion on this. So I believe, I mean, to answer your question whether the researchers should know about EOSC, I don't believe so. But it's true that we still have to build EOSC, so until still EOSC is not there, we need to create awareness about EOSC to make sure it happens. And I believe, in my opinion, one of the main achievements so far in EOSC has been this engagement of the member states. And I could see that also in my Nordic region, that also the country is less mature now. They are putting in place national roadmaps for open science, and they are getting organized. So for me, this is an effect of the EOSC movement, and that's really positive. So we should talk about EOSC, even if we have different definitions at the moment, but we are getting there. And then maybe in 10 years' time or 40 years' time, like the president quotes, maybe there is no need to know what EOSC is.
Thanks. Now in the panel we have 2 users of Blue-Cloud, so I'm now going to ask a couple of questions to them. So the collaboration between Blue-Cloud and FNS Cloud Network was useful to enrich the Blue-Cloud fishery virtual research environment via the FAO EU-FISH dataset. In terms of the GRSF, the Global Record of Stock of Fisheries description of fish items in the food value chain, to contribute to a better understanding of the nutritional contribution of fish to the food system, as well as to improve semantic interoperability between the 2 domains. So, Karl, a question to you. What was your experience as external user of the Open Science Blue-Cloud solution?
Thank you, Sara, for the question. Yeah, first of all, I would like to congratulate the Blue-Cloud for these fantastic achievements that they have done in the last 3 years, and more to come. We have seen some, looking very much forward to see. So the collaboration between the FNS Cloud, which stands for Food Nutrition Security Cloud, we also sometimes hear that the Food Cloud, and the Blue-Cloud was nice, also wished in the calls, and was kind of challenging, because as we have heard, that the Blue-Cloud belongs to the environmental cluster in EOSC, while the Food Cloud or the FNS Cloud is going more to the life science cluster. So we have not a thematic difference within a cluster, but we also have a different cluster, so there to collaborate. So this was just to set up. And what we did in one of the demonstrators, that we open up an API from our side, that we have some nutritional information on fish, so how many vitamins, how many minerals and macronutrients are there, and they is transferred to the EU-FISH 2 app from Anton FAO developed it. So this was kind of the exchange that we were there collaborated. So the experience as an outside user, let's say, was very, very positive from our side. So first of all, the Blue-Cloud is very much technical advanced. As we have heard, that's kind of a blueprint for EOSC, that we see a community who is doing very advanced things. So not only using the cloud as a storage, like many online storage for files, but they have a lot of advanced databases, infrastructure, repositories for data, and started also then now to go with software, cloud software, where they put it online, and even the infrastructure and platform as a service. So they use the whole range there, the technology, the ICT technology, and this was very inspiring for us, because we were kind of, a little bit, I'm always saying the Food Cloud, the FNS Cloud is 10 years behind the Blue-Cloud, and we're just building these databases, bring the data together, while the Blue-Cloud is much more advanced there. So this was, technically very interesting, inspiring. Sometimes I even wanted to kind of jump over and
work also with the Blue-Cloud. So this was kind of fun. And the other thing is also sometimes we feel a little bit sorry because then, or I felt sorry because the Blue-Cloud is taking care of the plants and the animals in the ocean, right? And then the food cloud, we're only interested in eating it. So I a little bit felt sorry about this one, but yeah, just that's how nature is sometimes. What's very interesting is also there where I would like to thank in the Blue-Cloud is the big support. So because when we started to collaborate, I needed to learn a lot of things, maybe also than Anton, or he was more advanced in the food point, so that we needed to learn from each other, also technically, and so there Schaap, thanks a lot, and Lina also as well for the technical collaboration to understand each other, and of course and Anton with the collaboration. So there is a lot of knowledge transfer, so I had kind of the luxury, I had all the technical coordinator, and then Anton can learn, I can learn from, I had private lessons basically from them, and this was very helpful. So this is also maybe something as a take-home message for the onboarding, the researcher. They need help. So even I needed help, I think they also need help. So this is something very important to remember. The onboarding with the researchers is something, they need a guiding because they're, as we heard this morning, they love to have their data on their machines working like this. But when they go to a cloud, they need a guidance there. This is also then, for us, it's also the collaboration was interesting to bridging to EOSC because we're kind of, we're a little bit at the beginning, as I said, and over the Blue-Cloud was also a little bit a door opener to go a broader community and see kind of EOSC as another picture maybe from me about EOSC is more as a roof, maybe as Dick also mentioned, is a roof where we see we all have common problems there, storage problem, computational problems, networking problems, and EOSC can also help there very much to bring some guidelines, back practices on paper that we can follow in such a community. And there the collaboration between the clouds was very helpful, so that we're getting into there and we learned from each other. Mostly the FNS Cloud learned from Blue-Cloud, but I think also we could give them some parts there. What was also helping for the fairness of data is kind of an external inspection. So kind of then when Anton wanted to get our data from the FNS Cloud, we needed to explain him, and then he asked some questions, and we thought, we have an issue, so we need to solve it, make it more fair, improve it, use more standardized vocabularies. That is, the data is also better clear for outside food scientists, right? And this was also was kind of an audit, I would say, like an external audit, a friendly external audit who said, okay, guys, you have some problems with your data and your APIs and the access, and so we could kind of improve this one. That helps very much, so and vice versa, hopefully. And also there, the part with the standards you're using. So if you're kind of using controlled vocabularies for your data to document or describe your data, we realized that all of the domains and the clusters, they have their own ones. But if you want to collaborate, sometimes you have a little bit of an overlap, but not fully, and you have to manage this somehow. So there is also kind of a collaboration going to harmonize controlled vocabulary, and of course also ontologies can help there. And so this is kind of the biggest benefit that I can describe.
Thanks, Karl. And since you come from the food industry, let's say, on one side, let's move out to the other side of the table with another industrial player. So, Delphine, you were part of the Blue-Cloud hackathon team that developed See Clearly, these tools used to advance simulations and tracking methods to identify the impact of marine plastic on aquaculture farms, as well as the impact of plastic pollution originating of aquaculture cages to the environment. You recently joined Fugro, one of the world's leading geodata specialist players. And given your experience of interaction with commercial entities, provide the audience with some recommendations following your experience from the private sectors, including not-for-profit and startups, and how to best exploit the Blue-Cloud open solutions.
Yes, thank you very much. So as you've just mentioned, I'm here kind of with two hats today. And I firstly just want to really thank the Blue-Cloud because I'm here with two of my other team members from Sea Clearly, and we really had a great experience. It was a great way to really get some innovative and creative ideas coming out of the science that we had been doing for many years in academia and bringing it forward to something that can be really applied to the real world. So this is the first thing that I think that's not just for academia, but also for startups, having this link between science and society and business. And so obviously a lot has been already said about the different applications and benefits of the Blue-Cloud that we also shared, and we also experienced, including identifying and using this publicly available data and having this repository where we could access it very easily. And then rapidly creating prototype software. So this was something which could really help us when we had a very quick solution we wanted to test. So it was a very interactive, and the fact that there were computational resources readily available allowed us to quickly test some solutions. And furthermore, we were a team across 3 different countries, and so the barrier of having to rely on local supercomputing facilities, for example, the Blue-Cloud facilitated collaboration across different countries. And then when it comes to the hackathon itself, the fact that we were all early career ocean professionals, it's a really important step to start bringing us to the table and to these kind of conferences and involve us in these kinds of hackathons, for example. Because it's not very often that academics can go out of their bubbles and really try to see where their research can be applied to the real world. So we were allowed the time, the space, the funding, and resources to really discover this, and we had mentors too, Anton, who's in the audience, and then we were also able to present our idea at many conferences, and so this allowed for very fast dissemination of our solution, and we see that the Blue-Cloud has a great network of open science and other players, and also with other stakeholders. So to really get to this point where we can apply these solutions, we were really presented to not just the scientific community, but also to the end users, of those who would want to look into our application, our tool for plastic pollution impacts in the Mediterranean. So now I can move on to Fugger a little bit, so on to hat number 2. And I would like to speak a little bit about the sharing of private data, because I know that this is a very, very big challenge, and it is very timely. There have been a lot of discussions recently that have started on this, and I think it's important to bring this up today. So I will present some of the challenges and some solutions too. So some of the challenges are legal implications. So often there are contracts that are signed that say that you can't share, that the data cannot be shared. And so a solution to this is really getting the legal teams involved and looking into legal requirements. So this can be, seeing if there are clauses that after 7 years, for example, of data, of the data acquisition, this data can be shared publicly. Then, for example, there are some companies that do not have a centralized place where they can send their data, store it, standardize it, sort it. So providing a platform like the Blue-Cloud eModNet, where these services can be facilitated and these companies do not need to spend time and money on those things themselves. That's one way, one way for sure to facilitate the sharing of private data. And then it's to actually look into the fact that there are private companies often do not want to share their data at the risk of losing the edge that they have on competition. So normally a financial or a commercial incentive is required in order to get them to be part of the community. So really working with them, looking at how you can provide a commercial or financial incentive, looking at some business models to make them part of the community, or else looking at ways in which their vision and mission align with what's happening in this community in order to maybe ask them to donate their data. And another way is to actually go to the source. So those who are acquiring data, for example, Fugro, this is the main thing that's expertise that is in the company. And so as opposed to going to the private companies, actually going to those that are acquiring the data and enable that new acquisitions. There are agreements between, for example, these repositories, those that are managing these repositories and the data acquisition companies in order to look at, for future data acquisition, that it can, however much data can be shared as possible, it's already agreed before the acquisition. And I think that in general, a gap analysis of looking at where the biggest need is and the highest priority of the data that is quite hard to actually collect publicly, and that the private sector does have quite a lot of, and looking at, and I think Anton was talking about this earlier today with the aquaculture farms and the satellite data, and really looking at okay, where are the biggest needs? Can we just pick out the key points of where there's private data out there and just focus on that, for example. And obviously some of the benefits of really looking into this and why I'm bringing it up is because the private sector can have a lot more data, because obviously there are a lot of investments into obtaining this data. And also there's a lot of these data sources have higher accuracy, high quality, high resolution, because they really need to be applied to the real world. So there are a lot of benefits into bringing them into the space. I can briefly talk about digital twins, I guess, if I have a minute or two.
Yes.
Okay, just because I think it's a good segue for the next session. Yeah. So at Fugro, we're currently working on developing a digital twin for the coastal resilience team. And so we're really looking into early warning signals and coastal hazard preparedness. And obviously, there is a lot of the components of digital twins are already being worked on by different people in this room in the wider community, and so it's very important for us to know, okay, who's doing what, and then we can really partner with people that and communities and initiatives that have already worked on components. I think it's important just to briefly talk about the challenges of digital twins and building them. So firstly, it's understanding data limitations. So with a digital twin, integration of data from many different sources, numerical models, observations must be done. And does it mean that once there's integration of all of these data streams, is there kind of a compounding effect on the uncertainty of the digital twin, or can it actually still be representative of the real world? And then maintain trust and fidelity with the end users is a very important part of it. And the way around this is just to remain realistic and and really looking at the expectations of the end users and making sure to deliver what is realistic. So, and mentioning this with the end users. And finally, I just want to say that digital twins are products, right? So right now we've been talking about kind of the step before digital twins, but if we really want to have the end users being a wider community than the scientists, then it's not just about the technical aspects that are and the technical expertise that is required to have a successful digital twin, but it's also looking at the actual end user experience and the user interface and getting the behavioral scientists and psychologists involved, because at the end of the day, in order for it to be used, we need to understand the users. All right, that's all for me. Thank you.
Delphine. I think it was a great point of view from the user perspective, and all the elements you've highlighted are strategic in the whole production line, let's say, of any of our tools. So I think we have 10 minutes left for some questions from the audience, if there are any. Feel free to raise a hand and then use the microphones you have. Yes?
Hi, so Dave Mills from Marine Centre Wales, so outside of the EU, unfortunately, for now anyway. Yeah, I mean, so many questions that follow from a range of interesting presentations. I mean, the challenge of addressing sustainable development goals is something we've been thinking about, and I've been thinking about, and it seems to me that we talk about citizens rather vaguely in relation to the digital twin. We have that inevitable challenge, and mentioned by Andreas, of bringing not only, if we had to address the challenge of delivering planetary and human well-being, then clearly we need to be able to draw upon disparate data sets across multiple domains, social, economic, and natural. Is this something we're moving towards? Are we, you know, where do we see what we're doing here as addressing these existential problems that we face? Sorry, that's rather difficult. And perhaps I could go
Andreas,
down to detail
yes.
if required.
Andreas.
Sorry.
I think we do. We move towards this point. If we approach that by, I mean, in the ENVI cluster we do the same. We identify sustainable development goals or hazardous risks where we need to develop, for instance, indicators as warning signs, or develop concepts and identify which kind of data sets we need to put together. And this is a bit of the approach I tried to describe before, that we identify the SDGs or the hazardous risks we need to tackle. And then from that, we go back and see what do we need. Are the data sources we need to access, are they already in the state they should be to build up services? If not, we have to do homework there. So it trickles down into the process. But I think if we keep the idea that all our questions and work is driven by these approaching these development goals or dealing with the climate change risks, if we use that as a driver, I think we go in the right direction. If we ignore that, we may go somewhere. But my honest belief is, let's take that as a driver, as a framework, as a guideline, and then we go in the right direction. With some detours, but...
Yeah, I'm just adding one other thing. I mean, because in the EOSC ecosystem, of course, I mean, EOSC is a bit agnostic, but of course the communities are super relevant. But for example, last week or this week, I don't remember, we organized this webinar where we tried to I mean, the narrative was following the Sustainable Development Goals, especially the climate action. And I think in there probably there was also one of the use cases where the community behind Blue-Cloud is also working with. And then there was something on health and something on innovation and infrastructures. So we try to look at all the actions happening in those EOSC projects. And from there, we were able to identify use cases that were contributing somehow to the Sustainable Development Goal. So just to say that maybe, I mean, it's not so evident that the trigger is the Sustainable Goal, like could be maybe with the missions. But of course, that's the final aim. That's what we want to achieve and work together for.
Michel.
Thank you. So yes, societal engagement is part of the open science approach we are trying to develop in Europe. We want to make it the norm in research. And societal engagement, for instance, as other open science practices, now in Horizon Europe is part of the evaluation process. So I want to say that there are different angles of attacks to achieve this societal engagement. One of them is with research funders in the way they do evaluate research proposals. And this is something we try to do in Horizon Europe, for instance. Another way is to involve citizen science, and I think this was mentioned in the roadmap 2026 of the Blue-Cloud. I saw it, and it's clearly a priority expressed by the member states also in the context of EOSC in the next years to come. So that's another way to tackle societal engagement. The third one I'd like to mention is reproducibility of results, because this leads to real trust into scientific wisdom. You mentioned wisdom this morning. And I think the FAIR agenda that we are trying to promote across disciplines is contributing to this reproducibility of results.
Thank you very much.
Yes, I have a question related to data management from many sources. So my name is Arne Barre from SINTEF, working in Iliad, Digital Twin of the Ocean, also the new Aqua Infra project, sister project of Blue-Cloud 2026. We are now in the EOSC context, and we talk about open science. Let's see if it was this. Yeah. But we also heard Delphine talking about industrial data. And obviously, a lot of data from many sources will be valuable to bring together. But if you look at the communities, they are somewhat disparate from each other. We have in Digital Europe all of the projects on European data spaces. We have the open science with EOSC. We also have the business data with the Industrial Data Space Association and Gaia-X. And this seems to be three separate communities that also have different technologies when it comes to, say, authentication, authorization, identity management, federation. Obviously, these communities should interoperate with each other in some way. So I wonder what the perspective is here from the EOSC and from the science community on, say, on one side, the public data community, and the other side, the business data community.
Do you want to start? Yeah.
Yes. One element of the response is, again, the FAIR agenda, because we strongly believe that fairness is not just an issue for the scientists. The FAIR principles apply to any kind of data, including industrial data, data owned by the commercial entities. So I think if we can mainstream our experience in EOSC from the research domain with respect to how to implement and assess fairness through the other data spaces of the European strategy, we can already do a good job there. Because yes, in the end, there is no clear wall between the public sector and the industrial sector. Innovation is based on any kind of data, and any data is a subject of research. So this, I think, this fairness aspect is important, and that's an element of answer regarding the data. Regarding the services, this is more a question for my colleagues in DG Connect, who are chef de file for the data spaces. But we can say that there are horizontal activities funded through the DEP program to support all the data spaces in a homogeneous way. So it's about providing a stack of open source software that can be reused by any community to build their own platforms. It's about a support center to promote data interoperability, not within a data space, but across the data spaces. So I think looking at those horizontal activities and linking EOSC and any activity at domain or subdomain level to these horizontal activities is will bear fruits, I think, in the future.
Yeah, Karl.
Maybe I can also add, because it's a very, very good question. I like it, because also then for me, my personal opinion is for a data space is first a data space if you have data from the research, from the industry, and from the government, right? So it makes it completely. So the community that you mentioned with EOSC, Gaia-X, so basically none of them can fully create in this way a full data space. So they need somehow to collaborate, right? So this is kind of first, and that some movements I see in this direction is that there are some companies already in EOSC, so there is a collaboration already. I also know one research organization in GaiaX, so also there including the research. And so that this being aware and asking this question also shows the both community that there should be a collaboration, exactly, having an exchange. I know from EOSC symposiums, they're mentioned also several times there and saying, okay, we should collaborate with GaiaX as well. And on the other hand, the second aspect I found also interesting is a little bit the competition. Of course, it looks like a little bit in parallel, but each community is kind of busy with itself, right, to formulate their requirements, their needs, the electronic needs in a sense. And then once they have it, we can start to collaborate, because then the community is more aware, more self-aware of what are the requirements, and then we can start to collaborate. So I think I see just at the moment as a stage one, where each of them is a little bit more independent, but they know from each other. And later on in further stages, they start to collaborate, because a data space is having included all of the three parties, basically.
Can I add
Yeah.
one thing? And I mean, I think it's also a problem of different timelines and different maturities of the different initiatives, and that's why it's still a bit complicated to draw the correct picture. But I think that, I mean, the collaboration with these initiatives, and with my other hat, I would also add the EuroHPC. I mean, it's natural that this has to come, because again, one of the point of I think also the vision of EOSC and these other initiatives is about federation, so about not reinventing the same things. So I think there is awareness that collaboration is needed. I think there are still a bit of misalignment in the timelines.
Yeah, thank you. It's a good point. I think maybe the AII of EOSC that already is federated could have something to bring to the others. I mean, there is a lot of maturity in EOSC already that might be transferred to the others.
If you allow, sorry. Yeah. Just one short remark from a scientific perspective to your point, with a bit of a different view. Honestly, I believe that the diversity of data spaces or data storages of wherever this is something good. It's not bad, it's good, because we come from a diversity of scientific approaches which have their specific needs and requirements and methods and tools for good reasons to serve their purposes. So, and that was our belief when we started the ENVI-FAIR project. We said the individual data systems at each operational research infrastructure must be maintained. They must stay operational because they are embedded in international networks. So, and the diversity it will ever be there, I'm convinced. And the trick is, or the challenge is to build a layer on top which allows communication or transfer from one of these data spaces, data lakes, however you call it, to the other. But we will never end up, and I'm pretty sure we will never come to a world where we have one big data lake, because for that the needs are too different for the different scientific communities. And not only scientific communities speak about public data or whatever. I think it's good that we have a diversity.
Yeah, and I think this is exactly the point of a data space versus a data lake. The data space supports heterogeneous, autonomous data sources, while a data lake is a natural collection for a purpose, which is also needed. But we will have a lot of data lakes, and we also need the interoperability between. So I think it's a good point to say.
Wanted to say something more? Yeah, maybe I can just add to conclude that there is another set of actions in EOSC currently running that is putting effort on the verification part of both services, digital object data sets, and they're trying to synchronize exactly the cultural, so the approach towards the usage and the mining and the data gathering, and they address topics that goes from PIDs to semantics, artifacts, and whatever we call them, to metrics, to assess the fairness of data up to trustworthy repositories, so going back to, but the first insights that we got there is what exactly Andreas said. The many differences across disciplines should take into consideration, of course, and we need to start from that as well. Okay, I think we are ready for a coffee. So I really thank all the panelists for today. Thank you, Delphine, Sara, Michelle, Andreas, and Carl. Thank you all. You have a 30-minute break, and then we'll convene for the last panel on at 3:40. So yes, 30. Sorry, 3:03.
Hmm? Yeah? When they're presenting, that might be nice. And then to go back to that slide, is that possible? Yeah. Do you know when we start? Whenever you want. Okay. Yes? Okay, welcome back everybody for the last session of today. My name is Kate Larkin from Seascape Belgium. I'm the Deputy Head of the eModNet Secretariat. So this is home turf, if you like, being based in Belgium myself. It's really an honour to be asked to moderate this closing panel today. So the closing panel title is Delivering a Digital Marine Knowledge System to Support the European Green Deal and the UN 2030 Agenda. So this is going to really look at ongoing and emerging initiatives that link Blue-Cloud into the future. So it's really connecting it also with the bigger picture, with policy into the future. But first, I'd like us to just take a moment to cast our minds back to when Blue-Cloud started. So the project kicked off, as was said earlier, in October 2019. So at that point, COVID hadn't happened yet, but most of the project was done during that time. But if you think of 2019, we already had the UN 2030 agenda well established. So the 17 Sustainable Development Goals were already well ongoing. And as Blue-Cloud has progressed, we've seen how the ocean observation, knowledge about the ocean and data has become ever more important, not just for SDG 14 on life underwater, but of course many other SDGs as well. Then in Europe, we already had the integrated maritime policy that was already, again, well underway with many different directives underneath that. But the Green Deal hadn't yet been launched. That was launched 2 months after the start of Blue-Cloud. So Blue-Cloud was really very timely because at the same time, just a year or so later, Europe released its communication on the European digital transformation. And that was the year 2021 when the United Nations Ocean Decade started, the Decade of Ocean Science for Sustainable Development. And so Blue-Cloud really has been at a very poignant and an important point in the development of both European and international policy. And as Blue-Cloud has developed, it's become increasingly clear how much the marine community in Europe is contributing to the delivery of this transparent and accessible ocean. So this is one of the key outcomes of the United Nations Ocean Decade, and it's really significantly enhanced and advanced this area towards an accessible ocean with open and accessible, equitable access, both to data but also to information, technology and innovation. So that's a little bit looking to the back, to the past, but now if we look to the future, the plan for today and for this final roundtable is to really share the status of these key European initiatives, projects and international programs that are seeking to build on Blue-Cloud and the wider marine community and to advance digital knowledge ecosystems in the marine domain. Also to reflect on how Blue-Cloud's results could be further capitalized by these efforts and importantly to link towards wider policy objectives, including the European Green Deal and the UN Agenda 2030. So without further ado, I would like to introduce very briefly our esteemed panelists. Then I will join the stage and give each of them the floor for their first interventions. So first, on the panel today, we have Marina Tonani. She is a specialist in ocean modelling and forecasting systems at Mercator Ocean International and Copernicus Marine Service. She is the digital model expert for the Edito Infra project. Welcome. Then we have Akrivi Vivian QC, who is the Senior Business and Innovation Manager at a net company Intrasoft International SA. She leads the coordination team for the EU Green Deal project Iliad, which is piloting services for digital twin oceans. Welcome. Next, we have Tiziana Ferrari, who's director of the EGI Foundation. She is a representative also of the GREAT project, which has just kicked off. That's a project looking at the Green Deal Data Space Foundation and Community of Practice. Welcome. Then we have Laurent Delaunay from Ifremer.
He's the coordinator of Jericho S3 and Jericho DS, leading an application for the European Research Infrastructure for Coastal Observations, Jericho, to the S3. And he also has two hats today. He's a representative of the International Ocean Best Practice Systems of IOC UNESCO. And then finally, we have Marc Taconnet. He's from the Department of Fisheries and Aquaculture of FAO, the Food and Agriculture Organization based in Rome, where he is the team leader of the Information and Knowledge Management. So welcome to all of you. I just want to check if the name tags are correct. They've been checked. Perfect. All right. So I'm going to move over to the center, and we're going to start the first slide. So please, Marina, you have 7 minutes. Take the floor and introduce. Thank you.
Thank you. So I'm the project manager of Edito Infra, and so I'm starting explaining to all of you, because I already discovered during the break that is not everyone familiar with this. So Edito is the European digital twin of the ocean, and the aim of the project is to build the infrastructure for the public European digital ocean. This project has started very recently, so we kicked it off in October, the beginning of October this year. So we are really in an early stage, but we need to define the architecture of this infrastructure pretty soon, because one of the key part of this should be the interoperability with all the other European assets. And so this is really important, because for engaging with all of you and Blue-Cloud that is hosting us today, we need starting very soon to define how we can reach this goal. And we try to sketch this schematic of the infrastructure, trying to explain how this can enable, this infrastructure can enable to reach this goal. And so, as you can see, the Edito is sort of the pedestal where we can connect the data source that are the data lake. And among this data lake, there are several existing European assets, like Copernicus Marine and Ebonnet. And then there is also Blue-Cloud. And this is a source of information that comes from observations or from model components for the past and for the future and forecast, together with tools that are the engine that are composed of complex models that could be numerical models or models that are using artificial intelligence, different tools like also the virtual labs developed by Blue-Cloud. These tools are all connected and federated in a way that they can use the data made available from the data lake and provide the actionable knowledge for the ocean that is needed for making decisions at different levels. And the information is meant to be for politicians, for scientists, for business people, for public institutions, and for the citizens. So it has a very broad auditorium. And this federated infrastructure is relying on the existing European assets without erasing their own identity, because it's federated, so we share part of it, but we keep also our identity. And this is an example for for example, for the Copernicus Marine Service that I represent here. So the Copernicus Marine Service is one of the source of information. It is the Marine Service of the European Community for providing information from observations and from models. And it has its own catalog of data, and this can be connected as a data lake to the digital twin of the ocean. But Copernicus Marine will continue to exist as its own identity, as Blue-Cloud will continue to do. So there is this mutual collaboration that is two-way, where we work together in order that we can enable a digital twin of the ocean where the information is available for all our users. So considering the users in a very broad way. So we are not categorizing users in specific categories, but it could be several types of users. And probably this is one of the challenges, because having a broad audience, it means also that you need to be able to provide your information in a way that can be used with wisdom, as already said by Dick this morning and repeated in the afternoon. And this is a very big challenge, I think, for all of us, and is also something that makes really important our collaboration, our work together, in order that we can make this happen. And there has been already several developments that make clear that even if this is a big challenge and is a very ambitious project, it could be feasible, because from all the presentation that we had this morning, we can see how much it can be done, it's already available, and how much we can build upon this in order that we can improve and provide further products. And what is really needed is this infrastructure that will also able to provide sustainability to the Horizon project, because part of the data that will be developed can be hosted in this infrastructure, so that can be sustained also once the project is finished. Then, of course, it's not for all the components, but could be for some of them. And I think that this schematic, even if maybe it's not very clear and with all the limitations that you can have in a single slide, hopefully provide you a more concrete idea than just my words on how this could happen, and how we are strongly connected each other for being able to achieve this goal.
Thank you very much, Marina. So thank you very much as well for highlighting and introducing that two of the key EU marine data services, EMODNet and Copernicus Marine Service, through the Wikio, they were both contributors to the Blue-Cloud in terms of the data services and the data. And now this is the next step, to really look at how to consolidate that as a backbone for the digital twin ocean of the European Union, and to link with other projects which are also piloting important services for the future digital twin oceans. So thank you very much, and that's a nice segue to our next speaker, Akrivi Vivian. Please, you have the floor. I will change the slide to introduce the Iliad project and the connection with Blue-Cloud. Thank you.
So as you can see, I represent a complicated and multidisciplinary team of 58 different partners. I lead the coordination team, and I'm very happy to do that. We go together because of business and research curiosity. So together, from what I heard, I was also listening to the part of the collaboration on the services provision of agreements. All that are considered from the team, apart from the scientific and the business aspects. Iliad is supporting several items that we try to depict it in this picture with the assistance of the Iliad team of experts. We can say that we support a federated ocean data space, including access to multiple data lakes. So we enable an ecosystem of interoperable digital twins. How do we do that? By connecting to existing ocean data infrastructures with additional observations coming from regional observatories. And what is also very important is that we assemble a broad and diverse user community. And I was also looking that Blue-Cloud also has a very important user community. In this occasion, we try to involve them throughout the project. So co-creation is one of the keywords that we used from the very beginning of the project. And we wanted to include them in all activities, both for the design and the validation, since we want to, let's say, keep a dedicated audience on board. Also, as you can see it, we tried to give a bit of the big picture, the international perspective, and we highlighted also DITO. We also connect to the DITO working groups. We lead the working group 5, architecture. So we also have to say some of the highlights on the fact of the twinning. We cover multiple continents, regions, coming from Europe, Africa, and Middle East. I also heard today about the question of the citizen science. We support a federated framework that includes also this capacity in several layers. I'm not the expert, but we have a dedicated work package to do that specifically. We also support new types of sensors, so this is the part of the innovation. And coming more now to the fact on the services side, Iliad is envisaging the concept of the space linked to the marketplace, a marketplace which is not only connected to the data sets, we also consider the modeling parts and the twins. So the part of the agreements that we heard from Delphine Lobel earlier is something we also have to investigate in this project, because also agreements are part of the collaboration and the business modeling and the monetization. We shouldn't forget that, because I forgot to mention that this is a NIA project and we got 19 million to do this from the European Commission. What is also very interesting is the concept of local and sector-specific digital twins, which are related to our pilot areas, so we can focus on local twins and give information to the different types of clustering projects. We also try to highlight in the picture different types of references and connections we emphasize, plus close collaborations with several projects. Some of the partners already participate in a similar project in the area, like Aqua Infra, which is a sister project also to Blue-Cloud. Now, on the connection, we identified it quite early. We met in the Digital Ocean Forum, so we already did a meeting with Blue-Cloud, so we envisage also a continuation within the new project. Iliad views Blue-Cloud as an important partner for providing access to the data that Blue-Cloud is organizing through the DAs, for example, Internet. All that is of our interest. And also we have several questions of how we can move on to this collaboration. So we want to further, let's say, provide some kind of alignments and see how we can look on the different qualities to do that. And that's all. I think I'm within the time frame.
Thank you very much, Vivian, for those words on Iliad, another key project and initiative that is working towards the future European Digital Twin Ocean. So now we're going to take a step a little bit wider. So keep in your mind all of the excellent developments in the marine domain, but we're now going to take a bigger picture and look at the wider EU Green Deal. And Tiziano Ferrari will tell us some words about a new project, GREAT, which is looking into developing the Green Deal data space. So please.
Yes. Can you hear me? Yeah. First, I'd like to say a few words about EGI, which is the organization that I represent, and how we have been supporting, thanks to DefoScience, the Blue Cloud community and the project. And after this very short introduction, I'd like to present how there's a project, a very new project, which is called The Great, will in the future bring the assets of Blue Cloud into a bigger strategy, which is the Green Deal data space. So the EGI Federation that I represent here is an international federation of about 200 data centers, primarily in Europe, but also in the United States, Canada, Africa, and Latin America, and Asia Pacific. And the characterizing feature of this federation is that it has been constituted to bring together research data, which is distributed and is coming from large scientific collaborations which have to share this data to extract knowledge. We are not a project. We have been in operations for 15 years, and we sustain data-intensive computing thanks to the funding coming from our members. Some of these are member states. So we federate national infrastructures which deliver high-throughput computing, high-performance computing, and cloud resources. And we also federate specific research data centers that only support their science. One and perhaps the four biggest example is CERN. With this experience, we have been supporting DefoScience with some of the virtual research environment pilots. Our approach to Blue Cloud is to bring this international capacity, which is federated and made available as a single computing platform to the users of the future Blue Cloud VREs. So it's a sustainable path towards using existing national investments and also giving and sustaining cross-border access, which hasn't been mentioned so much today. But it's a major sustainable problem when you want to support data access by users outside your organization or your country, and then you need mechanisms to recuperate marginal costs in accessing the data. And this is quite central to Blue Cloud and its future sustainability. So with this legacy, together with other partners, and in particular EMODNet, that is represented in the Great Consortium, we have been teaming up with a coordination and support action that just started, and is one of the coordination and support actions that the European Commission has launched as projects to define the future roadmap of data spaces, which have been mentioned a number of times during the conference today. And I like to say these data spaces are not existing or established legal entities. As you know, they are mostly informal collaborations, communities of practice, and projects. So when we say data spaces, these are really not legal entities, but are ambitious initiatives in the making. The Green Deal data space, I would say, is probably the most interesting, one of the most interesting data spaces which bridges science, industry, and policymakers. And you know this very well from Blue Cloud, because you have use cases which can serve usage from policymakers, but also industry, as we saw in another panel, and of course also scientific community. So Blue Cloud is an excellent use case for this specific coordination and support action. Other CSAs, similar to GREAT, are very industry-focused. So we have mobility, we have health, and other sectors which are strongly led by industry. And the Green Deal is really a pearl marrying these three different interests and potential of exploitation of data. All these coordination and support actions, GREAT is no exception, in fact have three pillars which are illustrated in a simple way here in the slide. The Commission is asking these projects first to come up with a reference architecture on how the data, the computing, and the data analytics, including the digital twins, will come together as an integrated asset which can serve cross-sectorial usage of data. So this element of architecture is very central, and we expect different data spaces will come with different reference architectures, which is perfectly acceptable. The Commission has launched a big umbrella initiative, which is the Data Space Support Center, which only started a month ago, which aims at harmonizing these approaches across different sectors. It's a very ambitious mission, as you can imagine, and even the Green Deal Coordination and Support Action has a very ambitious challenge here. The second pillar is governance and business models, which is quite important for the Commission to understand how these data spaces and agglomerations of data and applications can come together in a coherent business model, and there can be a number of these business models that are possible. And then the third pillar is the strategy on what are the key data sets that are really paramount and have to be sustained by public funding and European Commission funding in order to enable the access for all the sectors which are relevant to the Green Deal. We're not starting from nothing, so the Blue-Cloud project is a very strong foundation, and I hope in the panel we can also discuss how, thanks to EMODNet, we will bring all the experience to support input to these three pillars. But I'd like to also mention other projects in the context of the European Open Science Cloud, the GIA's project, which delivers the Computer Federation, the Seascape project, which is also looking at Copernicus Data Federation, including in situ data integrated with applications, and then Intertwin. Intertwin is an interesting project because it cooperates with Destination Earth and has a very generic objective, which is defining an architecture and a pilot where Destination Earth data, including the data lake, but also integrated data coming from third parties, will come together with existing research infrastructure data, for example, like EMSO and other research infrastructures, or also Blue-Cloud, CDataNet, and EMODNet. We have, so to conclude, very strong pillars, a family of projects which are advancing technology and advancing our understanding of how all these assets can be governed and delivered at European level. And we hope the Blue-Cloud project will be a very prominent player in this CSA. And I hope we can then discuss how Blue-Cloud can contribute to this project. Thank you.
Thank you very much, Tiziana. So all of these, you know, the European data space and the Green Deal data space, they all need these community of practices, these best practices. And so I'd like to now move on to Laurent Delaunay to hear a little bit about how, firstly, the Jericho Coastal Observatory research infrastructure has linked with Blue-Cloud in terms of the virtual research environments that has been produced, but also then taking a step further to see how these research infrastructures and how Blue-Cloud has built these best practices and how that is being taken to the international level, or how it could evolve to do so through the Ocean Best Practice System. So please, Laurent, you have the floor.
Okay, thanks a lot. So I'm Laurent Delaunay, and I'm coordinating the Jericho Observing Systems, and as well I wear the hat for Ocean Best Practice System today, because both of them are very interconnected, and collaboration is happening at high level, and with Blue-Cloud as well. But I will talk as well about other observing research infrastructures that are operating in Europe, because all of them are using best practices and standards in order to consolidate where ocean observation is made. So the Ocean Best Practices System is the IOC project that's sponsored by IOD and GOOSE program since June 2019. And this Ocean Best Practicing System is a sustained repository supporting adoptions and adaptations of best practices and standards as well. We all understand that the increasing need in terms to understand and sustain the ocean needs common and interoperable methods, and that covers the whole data chains. So the best practices and standards should cover the data we collect, the analysis we are doing, as shown on these slides, and as well the application of our informations. And I would say that these best practices and standards are surely the backbones of the observation systems, because these ocean and best practices systems helps to build trust. And this is a very important word for my talk. It helps to build trust through documented and transparent methods and standards. And it will serve the users of the data we are producing, the modelers, for example, that are not especially some data specialists, but so who need to know which kind of data they should use in order to build up some very solid and intercomparable model systems. It can be used as well by decision makers, decision bodies, in order to consolidate their decisions by looking after the level of maturity of the data they are using, so comparing them to see if they are flagged or attached to a best practices or standards. And as well, scientists. The scientist community is in front of such a huge amount of data that they should be able to access easily, and this is where Blue-Cloud is coming up, should access easily which methodology was used for this kind of data in this kind of region, for this kind of domain. So, as well, best practices and standards elaborations can stimulate collaboration across disciplines, and I think that this is as well a very important topic in terms of training, teaching, and as well collaborations. What I just presented you briefly are the goals of the ocean best practices systems, and I fully believe that they are as well the goals of the Blue-Cloud projects, and it's working, supporting ocean science. So I would like to precise as well that in the ocean best practices system, there is a very good community supported endorsement of best practices and standards that guides the selections of the endorsed methods. Then, if there are many methods, and there are, if there are many methods that are addressing the same EOVs or the same variable or the same parameters or the same methodology, these methods will be, there is a mechanism in the OBPS to endorse the method as much as possible in order to guide the users directly to the best one. As well, OBPS capacity development and works with developing region encourage uptakes of usable and effective methods. And as well, OBPS support projects, and as already said right in the beginning, support projects and research infrastructures, such, for example, Jericho, EMSO, Eurago, ICOS, and others. And as well, Blue-Cloud supports as well Blue-Cloud key developments, which can advance the way we do science and impact on the society around us. On these diagrams, you can see the connection of best practices and standards on the left side of the small diagram in the bottom in orange on the left side, and how it connects to the Blue-Cloud in the bottom that we can describe as the foundation element of the Jericho core diagrams. The Jericho core is an under development virtual research environment for the Jericho array. Then, in summary, I would like to say that best practices and standards in Blue-Cloud will be an important tool for the cloud, supporting efficiency, user uptake, broadening impacts, and developing trust in the data. Concerning the OBPS in the decade, I would like to say that we are, of course, addressing the three major sustainable development goals, that is the SDG 13, 14, and 17, that are dedicated to climate, life below water, and as well, partnership for the goal. This is a very important one for us. And we are focusing on developing a global consensus on how methods should interoperate and evolve into best practices and standards. And it's a major challenge in the path to realizing the Ocean Decade ambition. Here it is.
Thank you very much, Laura.
You're welcome.
So I'm glad that you mentioned SDGs, because that is a nice segue to our next speaker, Marc Taquanet. We've heard earlier today how much FAO has been involved in Blue Cloud and produced demonstrators that are very much linked with SDGs, but I'd like to now introduce Marc Taquanet to say a little bit more in depth about how FAO is working as a UN agency for these initiatives, and also the connection building on from Blue Cloud. Thank you.
Thank you, Kay. And thank you, Blue Cloud, for inviting me to this panel. I think I accepted because, indeed, I wanted to convey our experience at FAO to engage worldwide users in using this very nice infrastructure which Blue Cloud offers. And let me start with the fact that FAO, a UN organization involved in the fight against hunger, has this societal mandate to work with its members towards feeding a world and a growing population up to 9 billion people in 2050. So we need to transform aquatic food systems, which are also a key component of the food to people, and to manage in a sustainable ways fisheries and aquaculture. And for that, for managing, we need data and the best scientific evidence. So on the slide, you can see, well, the data value chain from field data collection in countries up to the science to policy interface with our flagship publication that we produced every 2 years. And I have the chance to supervise projects and programs across the whole data value chain. So I am lucky to be able also to influence and to contribute to bring this innovation in our mandate. In fact, we have been involved in EU infrastructure projects since 2008, I think across 7 or 8 subsequent projects. And what do we seek in participating in this project? We want to leverage innovation in IT technologies and data systems to support our members worldwide and offer solutions to the needs for science-based evidence. In our case, in support to fisheries and aquaculture. So throughout these 15 years of participation, I would like to say we walk through incremental levels of maturity of data systems. We started by we discovered confronting the statistical business needs of our global fishery community with the potential that the IT innovation could bring. And then we started to build in the first project and second convincing demonstrators. We've seen some of them here. And the following step was to improve them, but also to start thinking, developing a business model for a sustainable data infrastructure. But then this required really to go beyond the very inner cycle of the demonstrators, to develop the user community and to establish the governance through the different partnerships that we have towards an operational data system. But when we started to engage really the community for a sustainable business model, they started, well, we had no choice than developing further the data standards, the harmonization of data. Otherwise, they would not be able really, despite a lot of history of standardization in fisheries, to really work easily streamlined together and put their data together. So we had to go through 2 or 3 years more of adoption of standards. But now, let's say, with Blue Cloud, we can say that the results are there. Anton presented the Global Tuna Atlas, which we disseminate through our knowledge, as part of our knowledge base in FAO. It contributes to status of stocks analysis, obviously. The global record of stocks on fisheries as well. I have the chance to be the focal point for indicator 1441, state of stocks, and I could bring these values to the training that we developed to engage. We managed to engage 1,000 users in training sessions using the VREs, and I discovered myself that was one of the best avenues to spread the message. Now, we had institutions, now we have universities that have followed up without us inviting them to use the system. And these unique identifiers that Anton explained, we have shaped with IT standards in the GRSF. They are part of the SDG questionnaire that we launched last week, the second call. So we are draining all these innovations through the institutional processes. Yes, what do we do with Blue-Cloud 2026? Maybe the next intervention. Yes, with the Blue-Cloud project, it has had the novelty and potential of bringing a true multidisciplinary approach to marine sciences, which is highly welcomed. We have started also with some demonstrators to explore this potential. We have had aquaculture maps detection, marine protected areas assessment system in the previous project. We have experiments of predicting invasive species. There was this hackathon, mixing aquaculture and pollution data. So we step into that, but a lot of remains to do if we really want data interoperability to become a reality in EOSC. So again, my message is that a huge effort is needed to engage real user communities in their attempt to address these policy challenges. And I was trying to explain that there are strong roles for organizations like FAO, but we work also with many research institutions, with the private sector across the world to coordinate communities of practice, work with them hand in hand, integrate data flows, and bring eventually data services to operational level. And this is a long, long road. But you need, that's why I'm saying you need to have this institution with societal mandates. And I think there was a discussion on Blue-Cloud food nutrition FNSS, security maybe, whereby, yes, the technology can do it, but you must engage into, again, addressing a societal issue, to engage communities, to develop the same vocabularies, so that data collected by different communities, they can flow together. And that can only happen if you enlarge your user base. And I'm done. Thank you.
Thank you very much, Mark. There's a really nice conclusion before we open the floor for questions, to really see that these larger policy objectives like the EU Green Deal, like the UN 2030 Agenda, like Mission Ocean, they're putting these really big challenges in front of the community and making each community step up in terms of interoperability in its own domain, but then being ready to then exchange, as you've just said, between the marine and food nutrition domains, for example, but also health, socioeconomics, etc. So this is where everything is going, and it was great to hear from, thank you to all the 5 speakers for giving your insights into new and emerging activities in this area. I would like to now open the floor for questions, both in the room and online, before we take a sort of second round of looking at the future look. So please raise your hand if you have questions for any of our 5 speakers at this point. I'm looking at Federico in case there are online questions as well. Yes, we have a question, Alessandra, please.
Thank you. It's just, we have, speaking from the side of eModenet, coordinating one of the eModenet lots, and we have spent years to explain to our users the complementarity between SeaDataNet, eModenet, and Copernicus, and so on. And now I'm seeing the 3 initiatives that were presented here in this panel at the beginning, and what I have imagined that it's a 3-way, 3 perspective, 3 way of seeing the same elements of joining the same systems. So I would like to ask you if you can give, let's say, more details on the to answer the question of the panel. So how Blue-Cloud contribute to accelerate progress? So how do you in practice you will connect and you use Blue-Cloud and the different elements? If you can give more insight.
So would somebody like to answer from the panel? Please, Marina.
So thank you, Alessandra, for your question. So as I said, so the slide and so my introduction was a very schematic one, but we know how Varigate is the reality with several assets and several initiatives that are working on the marine area, but providing a different set of information. And so in my slide, I was focusing on EMODNet and Copernicus that have some interaction and they work together, but they are providing different set of information to the users, as Blue-Cloud is doing. So, and that, as I said, we will keep this initiative with all their value without losing the diversity that they bring, but we will integrate them in a way that can be easily accessible in the same way for the integration into a digital twin. So we will not integrate EMODNet, Copernicus Marine, Blue-Cloud all together and merging them, but we will keep them as they are, and they will work together in order to provide the best information possible and to contribute to the infrastructure and the information that we can deliver from a digital twin of the ocean. And Blue-Cloud is playing a major role in this because he is, as has been said also from my colleague from the panel, has this multidisciplinary approach that is really unique and is extremely important. And so this characteristic of Blue-Cloud will be very important and valuable in building our digital twin of the ocean and will not be merged with the other information, will be valued as it is. So it seems that I didn't answer your question, so Alessandra?
Okay, but and how does this answer differentiate or could be different in the other two systems? Or
with Iliad?
This is Edito and the digital twin that...
With Iliad, so yeah, so Edito Infra is building the infrastructure, and this infrastructure can connect all the different assets. And if you remember from my slide, Iliad is mentioned there because is part, can be part of the European infrastructure. So is a way to, let's say, federate all the information with a unique infrastructure, but maintaining their identity. And so it's different level of information that are provided. And what I'm trying to stress is that Edito Infra is the infrastructure. It's not the content of the infrastructure.
Please, Dick. It should be at the front of the arm, yes.
Hello? Working? Yeah. Now, I must say that your picture looks very simple. I really say too simple, far too simple, in fact. Because what I think you should, I would say you should look from a different perspective. I think we have a lot of workflows, and these workflows means that, let's say, we have a factory line, and people make certain products, and we go from level to level every time. The product, let's say, has a different added value. Let's say the next step. And we start with data and metadata, then we go to data products, and then we go to, let's say, knowledge products, and then we have DTO, which is then the next step, another factory line which says, I can use that output and create something extra. But you are showing a little bit like we have a data lake. Everybody dumps everything in there, and then you guys are going to make the knowledge. And that's ridiculous, in fact. So no, it is, because you say we are the infrastructure, and that's not true. We have many infrastructures. There's hundreds of millions already invested in infrastructure, and you just make a next step, which is in the process chain, the next level. But it doesn't mean that you replace or take away all these other levels. These are together the infrastructure. Okay.
Slide that now. No, you are right. I'm sorry that has been misunderstood. But so in the slide that I show, EDITO is the pedestal. It's not all the other components.
Yeah.
That is not part of EDITO. EDITO is the backbone of the infrastructure that is able to connect all the assets, but it's not any of the assets.
I think you have to do something about the presentation, because it's not.
If I may,
this is wrong.
I will just bring it back to. I think it really highlights what has been said earlier in today's discussions, that we have to remember the pillar, or the pyramid, I should say, of the full marine knowledge value chain. I think that is clear in everybody's minds. It's difficult in a few minutes to highlight that when you're asked to introduce one initiative. So I think that's important to remember. But the sustainability from the ocean observations to the marine data services infrastructures and the on-top applications is all important for the delivery of marine knowledge for the European Green Deal, UN 2030 agenda, and the rest. What is important is that going on from Blue-Cloud, the infrastructures, the research infrastructures, the data infrastructures that were such pillars underpinning Blue-Cloud, they are all working to sort of make themselves more interoperable, upgrade their own infrastructure. And so for the EDITO Infra project, it's bringing together EMODNet and Copernicus Marine Service, which are already existing European marine data services. It's the next step as the sort of backbone to this European digital twin ocean. It's not the full picture. Of course, there's a whole community supplying into that. For EMODNet, from January next year, it will be fully centralized, which again is a step in the process towards interoperability of marine data services in Europe. So I will see now if there are any other...
I can also
yes, please, Tiziana.
A little bit. So this data space governance is being modeled, and all these contributions have to be highlighted, and this is quite central also to this great project. So there will be roles as data providers, data integrators, data mediators, and different players in a data space can enrich the value depending on what they deliver to determine the user group. So for what concerns GREAT, I would say this is an opportunity to also investigate the business models, how these data infrastructures have been governed and how they are being sustained. And all these differences will be reflected in our use cases. So the plan is to run surveys where also this, how all these different players come together to integrate where it makes sense for determining the user groups. We aim at modeling it, and I think it's a problem because it needs to be tabled and understood. Yeah. Also in the European Open Science Cloud, there is, that was mentioned in the previous panel, there is a similar understanding, and I think in the architecture, which is fairly simple, they have outlined how different players can provide the federation element, the data infrastructure, which is a system of systems, plus the enriching services like digital twins, which can build on data which is coming from multiple entities nationally or at European level from the S3 research infrastructures. So it's something that needs to be further expanded, and it's important that every provider in this system maintains the branding and its value proposition, and the problem of the business channels, how you reach your target groups, and what are the best channels for that is quite essential to be successful. Mm-hmm. So I think the question from Alessandra is very important for us.
Mm-hmm. Okay, thank you, Tiziana. Would anybody else from the panel like to add, compliment? I'm sorry. Yes, please, at the back.
I'm coming from a bit of lack of knowledge here or ignorance. So here's a question. Maybe it's for Tiziana most pertinently. So FAIR is great, but it's not enough. I've used FAIR data, and I spent a lot of time compiling different FAIR data sets into one. So now when it has an implementation network, it's easier, because the implementation network set up certain standards for data, types of data that are included in the data set. So then it's easier to use the data. And for your presentation of the data spaces aggregates a lot of different data sources, if I understood the presentation correctly. And I'm wondering if there is a set of protocols, maybe like Gaia-X or something like that, that will be guiding the implementation and interoperability. I didn't get that from the presentation, and I didn't hear a lot. So I've heard a lot of talk about the need for operability, but I haven't seen much, and this is maybe my ignorance here speaking, I haven't seen how it's going to be achieved, because I'm a scientist, and I found these data sets, yes, they're fair, but using different methods for recording data, there's a bunch of difficult to use in a single application. Thank you.
You have different elements in your question, so I'll try to respond a few things. So if we look at the data strategy, and especially how the data spaces are being tackled in industry, their focus on FAIR is minimal. You can hardly see the FAIR acronym in their papers and architectures. So they give as assumed that the data will be discoverable. And the focus of industrial data spaces, including some of the lighthouse projects of Gaia-X, is much more on the data economy, which means how you enable bilateral exchanges of data, which has economic value, and what are the enabling services to allow that. And this is very different in the scientific community, where, of course, there is less, there's a different approach to data. The value is in the scientific impact or the new policies, if you are a policymaker. So the angle is very different. This FAIR is almost non-existent in the data spaces. And I'm not expecting, having seen other initiatives, that they will go very deep into what FAIR means in mobility, smart cities, etc. The interoperability thing is extremely challenging, and Gaia-X, we are a member, so I'm here as a disclaimer bringing my own understanding as a member, so I don't want to speak on behalf of another initiative. But Gaia-X is having a basic architecture and has working groups which are detailing and fleshing out how aspects of interoperability will be achieved. Gaia-X is not an infrastructure, it's essentially a set of interoperability guidelines. And then the data spaces can use these interoperability guidelines in their software stack and service stack to deliver services. So that's the approach in this large initiative. Then the question is how you make sure that these data spaces from industry will interoperate, for example, with research data coming from Blue-Cloud. This is what the great project wants to tackle, and this is, of course, like boiling the ocean. It's an incredibly complex task, and because it's an 18-month project, the idea is to focus on specific use cases for the Green Deal, which tackles specific policy areas and which integrate data from science, from industry, from other sources. And with these use cases, we will see what are the interoperability and the basic architecture that has to be put in place. With my experience from a federated infrastructure with many, many different providers, there is not a single set of standards you can typically enforce for every user community. You have a family of interoperability guidelines which can be applied to serve specific use cases. And I suspect this would be the conclusion in the Green Deal data space as well. I can't imagine there is one set of standards that will solve every problem.
No, and that's, I think, the idea behind the implementation networks in the FAIR initiative. And I realize it's absolutely not appropriate for the industry and that type of data. So thanks. That was a very comprehensive answer to a complicated question. Thank you very much.
Good. Thank you. Okay, we have time for one more question. I can see one just here, and then we'll move to the second round, please.
Yeah, thank you. So it goes back to the discussion we had in the previous session on data spaces versus data lakes, and not only the FNA, but the INR, the interoperability and reusability, which are important to create good solutions. So I think a data lake interpreted as collecting all the data in one space is really what we mean and what will come out of this. We have also the notion of local and sector-specific digital twins, where you essentially collect the data you need for a particular purpose and make sure that this becomes interoperable and reusable in that context. And I think we will have many of those. We talk about digital twins in plural, but there will also be a need for a large, say, European digital twin of the ocean with the temperature, salinity, ocean height, those characteristics that's already has been captured. So that will be one twin, but this will need to be interoperable with the other twins that might have higher resolution and additional information. And that's what the data spaces can support.
Thank you very much. So I think what we'll do now is move to the second round. That's actually a much shorter round. And what I'd like to invite each of the 5 panelists to do is to really share their perspective now of looking to the future of how Blue Cloud can further contribute in this project, Blue Cloud 2026, but also in collaboration with all the other initiatives and important projects that you've heard from. How can we move together towards this European marine digital knowledge system? And how can we really link that to concretely be fit for use for the European Green Deal, for the UN 2030 agenda and other policy objectives? So I'm going to start at the end this time with Laurent and go along. So you have 2 minutes each, please.
2 minutes. So I would like to say that Blue Clouds will help for visibility and access. This is perfectly clear. Because users, when they want to use data, I've been in a conference 3 weeks ago in the east of France that were dedicated to biodiversity. And we were some people of the room at this conference to show how research infrastructures in the marine domain can provide data. And I was amazed to see how all these scientists dedicated to biodiversity in general didn't know anything about how to acquire marine data, proper quality marine data. So there is a lot of work to make them appear and accessible and to know, to give the visibility to it. And Karl Presser this morning was saying that when you are working locally, you know what to do, but when you move to the cloud, you need some help. And I would say that best practices and standards can help providing controlled vocabulary, and then it can help to what Karl Presser was saying. And if this OBPS comes to the Blue Cloud, it will be easily accessible, and it maybe will help to answer to the Karl Presser questions. And I would like to finish maybe by best practices and standards available in the Blue Cloud can be a teach and a capacity development tool to help users to engage more effectively with the cloud capability. So I think it's very important that this kind of initiatives is linked to Blue Cloud, and it will help as well the research infrastructures to be visible and to be more harmonized and so on. 2 minutes?
Thank you very much. Under time, perfect.
Right, great.
Thank you very much. Mark, please.
Thank you, Kate. So I think I would continue my credo since we have a multidisciplinary infrastructure in our hands, is to bring into the services of the SDGs. We have 8 years in front of us of the fight against or the adaptation in the context of adaptation, to climate change. if I take just SDG 14, we address various targets, degradation of marine environment, pollution, ocean health, and acidification. This is the abiotic part. The biotic part is restoration of ecosystems, and then we have the sustainable use of marine living resources. And there are organizations, again, like FAO, IOC, UNEP, who share responsibilities in the SDG targets. And for example, FAO is moving in a direction where in its strategic framework, it is now having the objective of mainstreaming biodiversity in fisheries, which is also very much the agenda of the EU Green Deal and the Common Fishery Policy. I heard Pierre in other audiences talking about the challenges with which this Common Fishery Policy is facing. This week, and he talked also about that, the UN Biodiversity Conference, COP15. So we have really a number of opportunities to share and to harness and hook to the global and the EU agendas. I would also like to mention another forthcoming UN agreement on biodiversity beyond national jurisdiction, and they have made clear their need for a clearinghouse mechanism where there is a need for a capacity building portal, and I mentioned how strongly using VREs for training and building capacities of science can help engage and spread the good practices and the innovation in technologies of information. They also want an information sharing capacity which are compatible with multiple data repositories of relevance to the BBNG, such as fishery resources, marine genetic resources, we heard about genomes, area-based management, also with the issues of wind energy, for example, environmental impact assessments and legal databases. So you see it's really cross multidisciplinary, and there are these opportunities. So if you really want to engage your communities and make your system real, you can have this vision of engaging strongly with the players there. Thank you.
Thank you very much, Mark. Tiziana, please.
So for the coming months, we aim at engaging with the Blue-Cloud 2026 project and the stakeholders, also through the facilitation of Seascape. First of all, to look into the architecture of Blue-Cloud and how the Blue-Cloud architecture can be generalized and if it's applicable more generally in a Green Deal data space broader scenario. There is an interesting opportunity here. The architecture is being led by the group at CNR that has been working with JRC and has also defined the first paper, which is the foundation of the Destination Earth initiative. So there is interesting know-how in the consortium, but also ECMWF will participate. So in this activity, with the contribution of Blue-Cloud, we have the possibility to look into real practical terms on how what is being built in Destination Earth and the digital twin approach integrates with Blue-Cloud 2026. So this is architecture. The second element, which I've mentioned already, so I will be very brief, is governance. Blue-Cloud with the various data federations that are involved and the research infrastructures as interesting examples of how data governance can be implemented at European level. And this is a very interesting example for industry where there is less maturity. So governance is quite a central piece. And the roadmap, which is led by ECMWF, is also important. We expect this output will be used by the European Commission and other funders to decide what will be the future funding priorities for the Green Deal data space. And we would like to see, of course, Blue-Cloud and the community strongly represented there. So having your roadmap recommendations, which are already, I think, very clearly outlined in the strategy paper, will be a very useful input to the project. Yeah.
Thank you very much. Akrivi?
Merci. So, as I stated a bit earlier, we see as Blue-Cloud being able to contribute for ILIAD by providing a federated access to a VRE and DDAs. Of course, we have initiated this relationship that I mentioned that requires, though, discussion on little issues that can be major, like how we can organize single sign-on, how to support the usage of Blue-Cloud VRE to the digital twinning I mentioned earlier, because we need to have a type of reciprocal relationship as well, not only to get, also to give back. How to organize for federated catalogs. We can also see ways to contribute if you're interested on the citizen science aspects we mentioned. We have a very big activity already in the project and several others, but that requires that we start the collaboration, which is the keyword, the major keyword. I hear that how you can be complementary, who gives what to whom. So we need to understand that there are a lot of interoperability points, and we have to be reciprocal. And we have to be quick as well, because if we want to be innovative, things are changing. So let's put all these things into some milestones so the project can work together efficiently and within a specific time frame that, of course, I can give you information within your timeline and you can help me out so we don't replicate and use unnecessarily money from taxes, first of all. And of course, monetize. Unfortunately, I come from industry and I have to think of that as well at all times. That's all.
Thank you very much. And Marina, please.
Yep. So I would like to cite what John Bell said a few days ago in Cork, talking about the mission ocean. He will say that it is created by the people in rare places, and that the European Commission gives to researchers innovation support so that people can use science and make this transformation of the ocean that we love. And I think that is a very simple statement, I would say, but implies an extremely complicated work that is behind the scene, because saying so that people can use science, I think that all the scientists in this room can understand how this is complicated. And I think that this is the final goal for our twin of the ocean. So we need to be able to provide our scientific information on the ocean to the people. And in this Blue-Cloud, as demonstrated and in its roadmap going to 2026, that he has the full potential to contribute and enhance the capabilities for reaching this goal. And this is, can be achievable with a strong collaboration, so that it's not that the infrastructure is imposing or is defining standard and structure that are standalone, but it's something that is developed in this mutual collaborationship between all the federated assets that are part of it, because it's done for all these federated assets. It's done for you, it's not done for it per se.
Thank you very much, Marina. So, just by way of closing, really, we've heard today all of the fantastic achievements and outputs of Blue-Cloud. This has really highlighted the key European assets, in research infrastructures, in data infrastructures, in e-infrastructures. It's really elevated those and shown what's possible by bringing those together and connecting them with computing power and analytical tools to produce really important user applications. But that was just the pilot. This is now the beginning of the next step. And we've heard today from these 5 speakers how we're engaging with international initiatives already for user-driven applications at the international level as well. But how together as a community we are now stepping up the interoperability to make space for the future European digital twin and all of the innovations and applications which will hopefully spin off of that as well. We've also heard from the Blue-Cloud roadmap at 2030 that the next project, Blue-Cloud 2026, will be furthering this initiative in collaboration with all of these projects and initiatives you've heard from today. It will be further looking into how to develop an interoperable Blue data space federated into the European Open Science Cloud, how it will be an incubator of Blue data, but also of analytical methods and services, and how it will be building a trusted community of practice for the marine domain, which also links then with the EU Green Deal and the Great Project community of practice, and really bringing together these key best practices and standards, also linking with the international OBPS. And also, importantly, the governance, the business models which were developed initially in the Blue-Cloud project as sustainability and exploitation plans, but will now be taken forward to look at the more concrete going forward sustainability of the Blue-Cloud and indeed the wider marine data space. So I'd like to thank all of the 5 speakers for their insights. Thank all of you for your questions, both online and in the audience. And I'd like to give a round of applause to our speakers before we have closing words. Thank you. And now I believe we move to the closing words of the conference, which will be started by Nicolas Segebarth from the Commission, and then Sara Pittonet. Thank you.
My button, the other button. Yeah, okay, I got it. A bit unprepared. I did not read the agenda until the end, of course. So just to conclude, I think it was a very great event. Interestingly, to me, I think the open science world and the ocean world are equally daunting to me in terms of the number of platforms, initiatives, projects that exist. But yet, I think this event provided an answer to that, showing that everybody has its place and that the fact that these different initiatives and projects talk together will help to go to the real goal. Because at the end, what we want to do with all these actions is to make things differently in a very soon future. We cannot wait much to change the way we deal with the world. So this is exactly what we have in mind with the digital twin of the ocean. It is to build on all these assets and make sure that the data, the science is transformed into actionable knowledge by the users. So that means that we need to ensure that the science is transferred somehow in operations, be it by programs, be it by commercial exploitation, etc. But we need to make sure that we have that transfer of knowledge until in a manner that is usable to answer specific questions by users, be it the people dealing with fisheries, people dealing with coastal resilience, etc. So it is really the end game is to provide the answers to the problems of today and of tomorrow. And for that, of course, we need both to address generic issues, and that is what EOSC is doing, that is what eModNet are doing to try into providing all these generic needs. And then we need to make sure that we develop the specific application, the answer, or the tools to have the answers to be able to decide on our actions. So I think we're not there yet, but we are on a good direction. And as I said, the fact that we have all these people and all these initiatives talking together, building and collaborating is a very good thing. So that's it. The word is yours to do the real conclusion.
Yeah, thank you very much, Nicolas. And yes, so thanks very much to the team who helped me showing you this slide, because I want to conclude not with a final remark, but more with a welcome to the new Blue-Cloud 2026, so the upcoming phase. Many of you asked me today, what's next, what's new, what are you bringing as a novelty into Blue-Cloud? So I'll highlight a few things that I believe are those that will make the difference for the next year, that are very much linked to the needs that we've learned today. So first, on the left side, the data discovery and access services. So we are expanding the number of data
blue data infrastructures that will be federated, and further effort will be brought for further harmonizing and introducing verification aspects of the data that then fit into the blue and marine value chain, thanks to the collaboration with 13 now and 19 in the new phase data providers. The VRE is the backstone, and that will stay there, but will be further exploited. We are introducing workbenches. So this is a novelty, the new product. So for highly qualified data collections, this is something that will live then and give back to the big marine collectors and to the research in general as analytical products for further use by different domains. We are introducing some new virtual labs. So a couple will stay from our community, so the marine environmental indicators and the Global Fisheries Atlas. The other ones will evolve, and this is our practical response within the consortium effort to the United Nations Sustainable Development Goals, if you like. We're keeping on the community. So one thing we have learned from Blue-Cloud is that we can be very flexible. We had a plan which has grown, increased over these 3 years. We had extremely valuable collaboration with what we call the synergies projects. We've learned about Jericho, Jonas, but others that trusted us, that had open-minded enough to look at the services that we produce and started using it, giving feedback back to us. So the community will follow the same approach and will be still a core element of Blue-Cloud. We're introducing a training academy. So this will have let's say multiple aspects. One for sure will be the verification part led by Eurogoose colleagues, but there will also be a more generic training activities on the Blue-Cloud assets and products, the virtual labs. And then the big novelty also is what we call the DTO task force, which we still probably don't know what it will be, but for sure it's the linkages with these other programs that we are contributing to. So the digital twin of the ocean, the infra, ILAD, I mean all the others that we are collaborating with. So from tomorrow, actually, from the 1st of January, I can say we will start working on this, so you'll hear back from us very soon. And with that, I have a series of thank you also, starting from the top. I want to thank the European Commission first, because I think the support and guidance we've received from different people who followed us is really valuable. I mean, and the guidance is strategic, but it's not given for granted just because they fund us. I mean, they really believe in us. So. The European Parliament, of course, the presence of Mr. Karleskind this morning was a big achievement. We hope that this might bring further visibility to Blue-Cloud outside. The consortium, I mean, it's been an incredible pleasure to lead this team of 20 partners over these last years. And I mean, we all rely on human beings. So really thank very much to all the colleagues. All the partners' initiatives that I said met us, we met them during this journey, and that are helping us spreading the word and testing and making Blue-Cloud needed. The final users, we had individuals, so working with early career researchers has really been a pleasure, and you see that the future generation also needs the things that we produce. For today's event in particularly, I want to thank all the tech team and the supporting team here at the Residence Palace. They've done a great job. Special thanks to Julia and Seascape for coordinating the huge effort of building all of us here with a smooth coordination, and everything went well. And also my colleagues at Trust IT who helped that. And then the last thank you is for all of you being with us today, so we can now enjoy a wonderful cocktail, I think, outside. So thank you very much.